try to focus our minds on extreme events in the broad sense. And many of us, most of us, a lot of us are from research organizations. And so one of the outcomes will be to kind of think about how we think about the research required to support the practitioners and the authorities and officials who are dealing with extreme events. We've had an opening ceremony where we had quite a few inputs from various organizations of relevance to this meeting. And yesterday we had a sort of general focus on some of the science aspects, and then we looked a little bit about at the observations and early warning systems. Again, a very mixed bag of material, mostly because this is really a multidisciplinary group of people from the full range of interest and interested and affected parties involved in environmental in extreme events. And again, I stress we have, the climate science, we have people that are involved in risk and vulnerability assessments, we have people working on particular cases, we have people that are working in response and rescue, we have people here who are working in policy. So a really mixed group of people, which is a great thing, especially because we're looking to be integrated in our approach. It also has the disadvantage of having us spread our thoughts across different disciplines. That's both an advantage and a disadvantage. And so we've did a bit of group work yesterday where we sat together and held conversations about particular aspects we wanted to focus on. And it turns out that doesn't work so well, so we've adapted that activity a little bit this morning, which I will explain. And so today we will continue with that session, which is again loosely themed around observations and early warning systems, and then we will finish that session and then look a little bit more at the risk and vulnerability aspects and some case studies. Just on a program note, so just a couple of program notes. Firstly, we asked people who register for this meeting and asked for an indication of those who are interested in submitting their work as a paper for our special issue of environmental development. And that's proceeding. And I just need to tell you that the deadline for submissions is going to be at the end of July. So we're going to give you time to prepare those papers. And I will communicate with all of those, well, everybody, but those in particular who indicated what the process will be. So we're giving you some time to write up those papers after the meeting. Okay, and then about today. So today's program, we've got a few gaps in the program and one addition. So just to note that the third talk, which is Flash 2.3, is not happening. So we're just going to jump over that. And then there was another gap, which we actually had earlier, which is, I think it was 3. Where is it now? Maybe it's over the page. I think it's 3.9. Yes, 3.9 is also a gap in the program. So we're dropping those 2 flash talks, which I'm sure you are delighted about. So just for those that weren't here yesterday, we've got the 2 kinds of talks, got the keynotes and the flashes. And the idea of the flashes is to be short, punchy around the topics. All of the material is in the ebook that you got on the stick. Yeah. And then this morning, we've got 1, 2, 3, 4, 5, 6, I think, 6 minus 1, flash talks. And then this morning, we're going to do the second group activity. So again, I'll explain when we get there, but there's a color code on your tag, and that color code will correspond to one of the colors on the wall, and there's 2 outside, where you'll go to your groups. All right, so that was, I think, everything I need to announce this morning. And so we can begin the program, and we have got 1, 2, 3, 4, 5, 6, yeah. So where's our first speaker? There you are. Hi. I didn't recognize you. Hi. So our first speaker is Curtis Bailey. Bertus, this is yours. For those that don't know, this is the timekeeper. That's yours, and there's a. You can scroll with this.
Okay. Good morning, everyone. My name is Curtis Bailey, and I'm from the Department of Geography and Environmental Studies here at Stellenbosch University. My study focused on the effects of the El Nino Southern Oscillation and how it influences precipitation in the Greater Hermanus region. So for those of you who don't know, the Greater Hermanus region is a coastal strip situated within the Overstrand municipality, climatically within the winter rainfall region of the Western Cape province. So this region or town is facing increasing pressure or mounting pressure on its hydrological resources as a result of anthropogenic influences, such as increasing population size, and then also climatic factors and such as climate change and increased climatic variability. So recently, one of these stresses that's sort of become prominent in mainstream media is the El Nino Southern Oscillation, which I'm just going to be referring to as ENSO. Now, most of you already know that ENSO refers to interannual fluctuations in sea surface temperatures in the tropical Pacific. We know that ENSO influences climate, regional climatic patterns, and also in South Africa. Fluctuating between each two phases in terms of the El Nino, which is the warming phase, and La Nina, which is the cooling phase. Now, ENSO's sort of influence in the eastern parts of the country is more adequately understood, with the warm phase. El Nino is associated with warmer, drier, rainy season, and La Nina associated with a cooler, wetter, rainy season. On average, it's not an absolute. While this pattern is not as adequately stood in our part of the world in terms of winter cape, which is also true for the Hermanus region. So with this mounting pressure, and ENSO being such a big constant in terms of inducing climatic variability and also recently extremes, I thought it would be a good idea just to investigate how regional or global climatic processes may influence local precipitation patterns. So this study is focused specifically on the austral or core winter rainfall season, so that June, July period, and how ENSO influenced those patterns directly. In order to do that, I collected monthly precipitation data from 3 different sources: the South African Weather Services, the Overstrand Municipality, as well as the Hermanus Magnetic Observatory, which is now known as SANSA. I calibrated the data and then converted so there are the positions of the 3 stations. I converted the data to a 3-month running precipitation index to identify precipitation anomalies in terms of outliers for the austral winter season. So precipitation anomalies in terms of that index are values greater than 1.5 if it's positive and negative 1.5 if it's negative. Then to sort of identify the Nino periods in terms of El Nino and La Nina, I looked at the end of the autumn and the season to see if that El Nino and La Nina was still active. Whereafter I also looked at the end of winter to see was it still active throughout that winter phase to have sort of a coupling effect in terms of precipitation. Then I correlated the 3 monthly running averages using the Nino index. Of temperatures above 0.5 using a Spearman correlation coefficient. I use a Spearman for the non-parametric nature of the coefficient. And then in terms of my result, I had some very interesting results. So I found that El Nino was sort of slightly producing drier winters, but the relationship was not found to be significant. But interestingly, if I looked at La Nina, I found that it produced slightly wetter winters, and the relationship was found to be significant. So mind you, only 14 El Nino and 18 La Nina events were investigated. So that might be a limitation of the study and the results here. But it was interesting because it actually, if you look at the graph, and also from recent studies, it actually sort of contradicts findings by a very big study by Philippon in 2012, which found that areas such as the Cape Metropole had wetter winters associated with El Nino due to an expanding westerly wind belt associated with a negative southern annular mode, which wasn't the case here. Another thing that I found was that there was a lot of interannual variability in how ENSO may couple with precipitation patterns with many negative anomalies associated in the sort of 70s. And then when you go through the sort of 2000s, you can see that the La Nina events sort of start skewing your results associated with very wet winters. So I didn't include last year's winter, but we had an active La Nina. So I'm assuming that correlation coefficient might also have been higher. And you can also see that progressively it's sort of becoming more extreme in terms of those events, in terms of precipitation, with last year being one of the wettest years, a La Nina year in Hermanus, which it had almost 80% above average rainfall for the entire year, including winter. So the results show here that there is sort of a relationship between ENSO. I didn't evaluate exactly how that might relate to the Southern Annual Node, as I was only interested in the ENSO event itself. It produces some interesting findings for policymakers as well as local management. And again, it also highlights how the winter rainfall itself is not a monolith, how local climatic variables can influence pattern processes, as well as sort of reminds us to look at how regional and global processes can influence more localized patterns across multiple spatial scales. Thank you.
You're up next. Okay. Thanks very much. So we're going to whip through these flash talks. Thanks very much.
Thank you.
We call you Willem or we call you Stefan?
Stefan. Yeah. Blame my parents. Good morning, I'm Stefan, and I'll be speaking to you today about the extreme rainfall season observed over Western South Africa last year, and specifically in the winter rainfall zone, which is this region between far southwestern Namibia and Cape Agulhas past Cape Town and where we are here in Stellenbosch. This region falls across the Western and Northern Cape provinces. This region was in the news prominently between 2015 and 2017 for an extreme unprecedented drought that almost led to the day zero running out of water. And then there was another extreme drought in 2022 until December. And then the 10-month period from December 2022 until September 2023 was one of the wettest 10-month periods in over a century of records over this winter rainfall region. And that's what I'll be talking about today. Not only was it extremely wet, it was also in this dark blue region here in the ERA 5 data, it was the coldest March to September period in the 1959 to 2023 record in terms of maximum temperatures, which is extraordinary given the long-term trend towards increasing temperatures that we heard about yesterday. The wettest month during this period was June 2023, which was associated with two extreme rainfall events. One, a protracted atmospheric river event between 3 and 19 June, which was associated with these two pockets of large column vapor anomalies in the southwestern, southeastern subtropical Atlantic, and then a cutoff low that came at the end of the month. These two pockets were the second, both of them classed as the second highest values in the record between 1959 and 2023, with the highest occurring in 1962, which was another very extreme June rainfall. And other months that also had similarly extreme rainfall were in 1976, 1942, 1925, and 1921. Unfortunately, all of those occurred before the satellite period, which limits our ability to compare the circulation patterns in the extratropical southern hemisphere. However, the rainfall totals at least 5 stations in the winter rainfall zone for June 2023 exceeded 700 millimeters, and at many stations, more rainfall occurred in just June 2023 than in the entire year of 2017. Extreme rainfall associated with cutoff lows also occurred in December 2022, February 2023, March, May, and again in the most extreme one, the Heritage Day floods of September 2023. As a result, the total rainfall for that 10-month period saw very large rainfall anomalies, especially here along the meridional mountain belt of the Cape Fold Mountains, and with the largest relative anomalies in the generally drier northeastern and eastern margins of this mountain belt. To illustrate the extremeness of the anomalies at Voelvlei Dam, which is situated here in the region that saw the largest relative anomalies, where there are records from 1957 to 2023, the hydrological year of 2023 saw the wettest December, the wettest March, the wettest June, and the wettest September on record. And if we assume that these events occur independently, the chance of seeing at least 4 such record-breaking months in the same calendar year, or sorry, the same 12-month period, is around 1 in 40,000. So that suggests that either this was an extraordinary coincidence or there were a combination of driving factors that persisted through this seasonal period that enhanced the probability of extreme rainfall events throughout the season. And so we explore what those factors might be. Somewhat further, 2 factors that were consequential probably was the southern annular mode was largely negative through winter and spring, much more so than in recent winters. And simultaneously, the extratropical zonal wave 3 saw its largest amplitude on record. And the phase of the zonal wave 3 was positioned such through most of the winter that it supported directing moisture across the South Atlantic towards the winter rainfall zone in South Africa. These are by themselves not sufficient conditions for the extreme rainfall that we saw, so other factors are very likely to have also been involved. And then finally, we found that the spatial patterns associated with extreme rainfall from atmospheric rivers and from cutoff lows are different, both at the larger, coarser scale, but also at the small scale, even within municipal boundaries. And this may have implications for disaster risk management at those scales. Thank you very much.
Very much. I forgot to mention that in case you were wondering, I am not a Johan Stander. He was meant to chair, he's over there. And he gave me the honor of utilizing his time. So we had one talk which didn't deliver the remote video in time. So we're skipping over 2.8 and we're going to go to the video for 2.9, which is from Leonia, and it deals with climate change and children's health in the Free State, a general climate story. So let's hope it plays.
Hello everyone, my name is Sonia Ahmed. I'm going to present to you my study titled Climate Change and Children's Health in the Free State, Challenges and Solutions. Climate change is currently the greatest threat that humanity faces to global health. This study examines the impacts of climate change on children's health and identifies problems and suggests potential solutions for both the present and the future. This is a mixed method research combining both secondary qualitative and quantitative research designs. The study was conducted in the Free State Province to investigate the impact of climate change on children's health. The secondary qualitative data was analyzed by Atlas TI, while the secondary quantitative data by Stata. Figure 1 shows the results on the impact of climate change on children. Youth unemployment in South Africa is as high as 61.7%, though malnutrition is very low at 2.5%. Children poverty between the ages of 0 to 17 years is high at 60.0%. And in the Free State, children poverty is as high as 53.8%. Table 1 shows the results for major issues of climate, energy, and environment on South African children. When we look at the impact of climate change on the health of children, we can see that in the Free State, there were instances of malaria outbreaks caused by heavy rainfalls and floods, and this affected the health infrastructure. There were also cases of respiratory illnesses due to reduced air quality, and also children suffer from asthma and TB. When we look at nutrition in the Free State, heavy rainfalls and floods affect the agriculture sector so much that there is shortages of food, and this leads to starvation and undernourishment in children. Also, when we look at the emotional and social well-being of children, floods and droughts cause emotional distress in children. And when they are not given enough official support system, such as counseling, they become very stressed. Now, figure 2 shows the climate change solutions for children. It is important for the government to implement climate change adaptation strategies, such as programs and projects that help the children to be resilient to the impacts of climate change. Also, it is important to reinvent energy sources to reduce air pollution and respiratory illnesses amongst children. It is also recommended that buildings should be designed in such a way that they are energy efficient in order to attract low energy bills and reduce air pollution and improve indoor and outdoor air quality. There is also need to increase access to fresh plant-based foods to lower the greenhouse gas and air pollution, and also to improve the heart, to promote heart health and reduce risk to cancer, obesity, and diabetes. Also, fresh plant-based food is encouraged in order to reduce greenhouse gas and air pollution to prevent diseases among children. In conclusion, it is crucial to understand children's vulnerability in order to promote evidence-based planning. It's also important to conduct research on risks, vulnerability, and likely impacts of climate change on children, youth, schools, and communities. This will provide decision makers with a better understanding about why children are particularly vulnerable and how planning might help reduce their vulnerabilities. It is also important to promote children's participation in the policy-making process and their visibility increased. The visibility of children should be increased in climate, energy, and environment. Climate policies and programs should target children, adolescents, youth, and women. Policies, plans, and programs should address their needs in responding to CEE strategies. Finally, the policies and strategies related to children, gender, and education should focus or discuss the impact CEE has on these vulnerable groups, which are children and women. This is the end of my presentation. I thank you for listening.
Thanks very much. We have 3 more presentations before we go to the group work this morning. So next is Michael. Thanks, Michael, who's got his presentation as a slide 1. There's a microphone here. There's a pointer there, and then you can scroll down with that, Rose. Thanks.
Good morning. My colleagues Heidi Hawkins, Uriah Van Alt, and Tim Hoffman and I are interested in this question as to whether climate is driving changes in vegetation. And you see, we've posed this as a question here, and I can give you a short answer, and that would be not much. For those with a longer attention span, I can go through the details of this. Globally, we know that phenology and vegetation density has been related to climate. And so it's a fair question to ask whether that is the case for South Africa. So this map summarizes what we did. Very simple study. We took weather data from ground stations. And the reason we used ground stations was that we compared ERA 5, CFSV2, MERA, Terra climate with each other and found them inconsistent. And we also found them inconsistent with the weather stations. So we trusted the weather stations rather. And so each of these points is a point representing a weather station that we used. And we also sampled protected areas for enhanced vegetation index from MODIS. And those are averages for each of the protected areas. This map shows the protected areas that we used. The ones that are colored in cyan are the ones where there was a positive change in EVI. There were no other significant changes across the country. So this is our climate data here. Each point represents an anomaly for a particular station, and the black points represent the averages for South Africa. And you see that there is no change in mean annual precipitation across the period we observed. That's 1980 to 2023. To our surprise, mean annual temperature went down, and maybe a climatologist can explain this to me. And significantly, there were 19 stations that exhibited significant changes in rainfall, and 18 of those were negative. Sorry, 18 of them were negative for mean annual temperature. T max increased dramatically, and T min went down. And so the T range went up by 0.8 degrees per decade, which is pretty staggering. And at the same time, there were wind changes, wind direction changes, and wind speed changes that were pretty consistent across the data set. So from a climate perspective, things are changing, and we might expect the changes in temperature to have some influence on the enhanced vegetation index. So let's take a look at that. So the top left plot here is the enhanced vegetation index. Again, the colored points represent each of the parks, and the black points are the area weighted averages. And we see that there's no particular change over time in that EVI. Now, this is a complicated measurement to interpret because EVI, of course, is also influenced by fires, herbivory, alien invasions, alien clearing, CO2, possibly, and then climate. So this lack of change is difficult to attribute to climate alone. And for some of the parks, when you look at them, you can see a big change in EVI, and you can go and look at the park and see, oh, there was a big fire in that year. So those things do influence the signal. But there were also no changes in seasonality of growth. So this is the start of the growing season, the peak of the growing season, and the end of the growing season. And you see there's not much change going on there. So in conclusion, we're not seeing a great deal of change in EVI in response to climate. That's it. Thank you.
Thank you very much. There's lots of questions that occur, but we have to move on, and we'll leave that to your tea break. Okay, so we have two more that I'd like to get through before we go to the group session. The first one is a video presentation, right? Yes, it's 2.11. Yeah. Start.
Greetings. I'm Lucy Wemaduna from the University of South Africa. I will be presenting to you the research that I conducted with my colleague, Professor Ilunga. We did a study in Newcastle, KwaZulu-Natal, in South Africa, where we assessed how climate change impacts rainfall patterns in the area. The rainfall trend was assessed from the period ranging from year 1991 up to year 2020. And the observed rainfall data that we used for the study was from the Newcastle Weather Station, which we obtained from the South African Weather Services. We then made use of the Mankandel test to assess the rainfall trends on monthly, annual, and seasonal timescale. The findings from this study was to be used to improve water resource management planning and decision-making in Newcastle. I have figure 1, whereby I have presented the observed monthly average rainfall for the period of 1991 up to 2020. And the graph shows that the highest monthly average rainfall was observed in the month of January, followed by the month of March and December. And the least monthly average rainfall was observed in the month of June, followed by the month of May and August. When we did the Mankandel monthly trend analysis, it showed that the rainfall trend was decreasing in all the months during the study period, except for the month of January and September, where January was having the highest increase in rainfall. And then I have figure 2, where I am presenting the observed rainfall data between 1991 to 2020, where we assessed this observed rainfall for annual and seasonal trend. The annual average rainfall was detected to be 35.13 millimeters. And the Mankandel test showed that the study area was experiencing a decrease in annual rainfall during the study period. And at a seasonal scale, it was detected that the summer season was the season that was experiencing the highest rainfall, followed by the season of spring and autumn. And the season that had the least rainfall was observed to be the season of winter. When we did the Mankandel trend test to detect the trend in seasonal rainfall, we discovered that all the seasons were having a decrease in rainfall, and that the significant decreasing seasonal rainfall trends were in the season of autumn, summer, and winter. Based on the findings that I have discussed, we then concluded that the climate change has a negative impact on Newcastle's rainfall pattern, as the rainfall is decreasing annually and seasonally. The decrease in rainfall can mean water scarcity and possible droughts in the Newcastle area. These findings are useful and will help the area's water resource planners as well as other stakeholders to assess water availability and also to be in a position to design appropriate water storage in the area. Thank you so much for listening.
Okay, thank you. So our final input this morning before we go to the groups is from Christine Engelbrecht, who will talk about her heatwave work. Thanks. Pointer. And scroll the arrow key and there's mine.
Thanks, Neville. I think I'll immediately scroll. Okay, so this study is a first step in an attempt to derive a heat risk map for South Africa. So here, only the climate part or the temperature hazard in terms of moving towards the development of a risk map is presented. So, and the way the climate or the temperature hazard is approached is to look at the different phases of ENSO, as ENSO is a very, basically our most important climate driver for the South African region. So here on the top part of this panel image is actually a 6-panel image. Maybe just quickly explain, the top panel represents the El Nino summer seasons over 45 summer periods, and in this case, a summer period is considered as a summer half-year period, so from October the one year to March the following year. So here on the top and on the left-hand side, the anomaly maps for the heatwave days. So the heatwave definition used in this study is the one used by the South African Weather Service, where the temperature at a specific location needs to exceed or needs to be warmer than 5 degrees Celsius of the warmest month. The long term, based on the long term mean, the warmest month for that specific location, and it needs to be present for at least 3 continuous days. So here on the left-hand side, top, is the anomaly map relative to the 1991 to 2020 long-term mean heatwave days climatology. So we can see during this 15 El Nino summers, during this 1979 up to 2023 period, our hotspot area is here over the central to eastern interior regions, and in terms of temperature as a hazard and moving towards a risk map, it coincides with very important crop production areas. Here on the middle image, now there were 17 La Nina seasons during this 45-year period. Here we can see in terms of the anomalous heatwave days, the greenish area indicating less than normal the frequency of heatwave days. Then just moving temporarily towards the bottom graph, this will be for neutral seasons, so neither an El Nino or La Nina stay present, and here we can see some mixed signal. But with some focus here towards the western parts of the country experiencing an increase or anomalously positive frequency in terms of heatwave days. Now, just to conclude, going up again. So on the left-hand panel, it was like the frequency of the anomalous frequency of heatwave days. On the right-hand panel, for those same heatwave events, looking at the maximum temperature anomaly for that specific heatwave day. So you can see as I scroll down, and again now the frequency in terms of the number of heatwave days per summer season for the October to March period differs quite dramatically between, let's say, our Nino season versus La Nina season, as shown earlier on. But when looking at the maximum temperature anomaly for those events, you can see there the reddish colors more or less consistent throughout the different phases of ENSO. So just telling us, and to me that was actually quite surprising. I actually thought that one would expect to see the maximum temperature anomalies for heat wave days during El Nino seasons would be maybe somewhat warmer, but to my surprise, very much comparable to those maximum temperature anomalies of heat waves during La Nina seasons and neutral seasons. It's just the frequency that is the difference. And again, converting that eventually to a risk map and moving towards applications of the specific hazard for a specific sector that can have some implications, trying to develop a risk map actually quite a little bit of a complex exercise. Thank you very much.
So a heat wave is a heat wave, no matter when it happens. Okay, thanks. So those are the inputs, and yesterday we started this session with several inputs. Need to put up the group exercise slides. So we're going to again pick your brains, hopefully that you will both have an enjoyable and useful conversation. Just to remind you what we did, you're going to go back into the same groups that you had before. We'll see how the conversation's going. We've scheduled, let's see how much time. Just about an hour for this, but we'll see how the conversation goes. And then after that, we'll come back and see what contributions there are. Just to remind you, to go to the next slide, please. What we're doing with this, again, for those that were here yesterday, so this is not just a fun exercise. We actually want to use this output and collate a document from the various group discussions that we are going to have and various other kinds of inputs. And we're going to deliver this to our principal organizations, namely S&T, Scope, and the three entities here are two departments, Forestry, Fisheries and Environment, and Science and Innovation, and the Presidential Climate Commission. And also collect this to be published as part of the special issue as an editorial or a paper, depending on what we can produce. Next one, please. So again, we did try to disaggregate the thinking so we could re-aggregate it and acknowledge the intersection of the various different interests and emphases and disciplines that are involved. We slightly adapted that based on yesterday's exercise. We'll see how it goes. Next one, please. So to remind you that what you have to do is, well, you can use the same people who volunteered yesterday to be chairs and scribes and rapporteurs, or you can rotate those if you like, or pick another victim if you need one. And the idea is we've provided you with some discussion idea, but we don't want to limit the discussion. We would like to see some direction. Next, please. So yesterday we asked about the science and we got some science back, but we also got some other stuff back. Next one, please. So today we thought about trying to focus the discussion around the theme of this particular session, which was about the data and observations and early warning systems. And again, it's critical that the chair/rapporteur gets that result written up in an email, at least to me, so that we can collate it all. And so we've decided to change the question a little bit. Yesterday, somebody pointed out that it seemed very science-driven thinking. So we tried to not think like a scientist. No, that's a joke. That's a joke, promise. Offering these two as guidance for the discussion. So the first one, and this also comes out of yesterday's conversation, both in the plenary and in other conversations in the building, which was we can't skirt around the data issue. And so aside from, this is the question, aside from increased and denser weather station data, what other data should be acquired, and this is the critical term, made publicly available for use in early warning systems? Who should pay for it? Who should manage it? And who should own that data? So that's, again, a conversation starter. You're not limited to discuss this or answer this question, but hopefully it will stimulate the conversation we'd like to direct. And then it asks, how should we report, or should we report on the likelihood of occurrence of an extreme weather event? For example, a Bergwind. There was another name you used with an L, phone with an F. A heavy rainfall event, or the likely impact of such an event, such as a risk of fire or flooding. So the question is, how should we report and distinguish, or should we distinguish at all, on the likelihood of the occurrence of the extreme weather versus the impact of such an event? So how do we communicate and use the information we have, and what is the composition of such early warning systems? That's the kind of conversation starter. So those are the two. Again, I emphasize it's the tinder to start the fire, and hopefully you will take this conversation and produce us a couple of bullet points which are important and that we can use to compose our output from this meeting. All right. So please have a look at the color on your tags, and those that were yesterday will know where you assembled. So that's blue, red. That was red, blue, black, and that's green, isn't it? Yeah, yellow, and then there's another reddish color outside, and a third one. Forget what it is. Maybe a purple or an orange. Okay, so. Please use the time to get to know other folk, have a chat, enjoy it, please, and we'll keep tabs and call you in for the plenary. So please, now's the time. There was a question, sorry. We can certainly do that. Why not? So before we break, William has suggested that we take a few questions about the flash talks. So let's take a few minutes to do that. And you have to start now because you set us going.
We know that we have parts of the country are winter rainfall, parts of summer rainfall. You might expect some degree of difference in response over time. So your data that you showed us was just a smudge of the whole country. Did you not try and break it up a bit into either climate regions or biological regions, different biomes, for example?
Yes, indeed. We've done an analysis per biome, and the patterns are pretty much consistent. There's not much difference between the biomes and their responses.
What a shocker.
Okay, well, let's use the opportunity. Are there any other people that wanted to make any other points or questions about any of the flash talks? Godfrey.
Thank you, Facilitator. Good morning, colleagues. Just on a technicality, I know a lot of authors like to say South Africa is Southern Africa. South Africa is South Africa. It's not Southern Africa. I know you might want your work to be published, but I've seen this repeated in many writings. It confuses readers. The other one is actually the response to him who's saying there's no difference across the biomes. This is quite interesting for me because these biomes have got different levels of tolerance to extremes. So then if your findings say there's no difference, or maybe if you say there's no significant difference, maybe we might take that. But the one to say there's no difference, even if I have not been to grade 7, I'll say no. Bottom line is grade 7.
Thank you. All right. Anybody else have any comments, responses, questions? It appears, William.
Sorry, I think it's only fair in the speakers, but I was surprised at the Hermanus talk. How much do we know about regional variation in the El Nino impacts? I mean, do we not worry about it in the Cape? Is it going to be, the west of the country might He's suffering from drought and all kinds of horrible things, but in the Cape, we'll be fine. Are we being suckered here? In other words, how much regional variation is there in the impact of these big oscillations? So it was very interesting to hear that paper, and I'd like to hear more from him perhaps on how general his results are.
I'm going to look to UCT Oceanography, Ross. Oh, Stephanie. No? Well, I just want to say that there are quite a few papers published about ENSO impacts on the Western Cape, and there are signals. They're obviously not as strong. I'm not speaking authoritatively. I'm heading towards oceanography over here. And I've always wanted to say this publicly. My father used to say that when it's raining in Joburg, it's blowing in Cape Town. Or when it's blowing in Cape Town, it's raining in Joburg. And I think that there's a strong link between wind and ENSO down here. But let's just hear from Ross.
Yeah, so ENSO is very much a summer-related phenomena. So it peaks in sort of November, December, January. So winter rainfall, the effects is more likely to be early winter rather than the core winter. So you've got to be very careful between looking at ENSO and winter rainfall, considering that ENSO is more when it peaks in summer. And Neville, you're right, it's the winds. So what ENSO does is influences the South Atlantic high-pressure system, which is responsible for our strong southeasterlies. That moves and changes in intensity because of ENSO during summer. So our winds completely shift. And I can't remember the exact way around, but I think it's during El Nino, it's maybe weaker winds and then stronger winds La Nina, looking at Stefan, yeah, and stronger during La Nina. So that's for the Western Cape region. That is where ENSO hits us. It's the summer rainfall region that's most likely hit by ENSO, and it's not the same across the region. If you look at simple correlations between ENSO and rainfall, there are patches within South Africa that actually show very little statistical relationship between ENSO. Northern KZN, for example, during El Nino events, I think out of 9 out of the 10 events have had the correct signal, but just further south in southern KZN, it's probably 3 or 4 events out of the 10 ENSO. So it does differ quite widely across South Africa, and each ENSO event is different. So from a forecasting perspective, it's very hard to say. That's why they generalize, saying Southern Africa is going to have below average rainfall. But when you actually break it down to each individual event, it's different. And sometimes, like the 97, 98, there was very little impact, whereas 2015, 2016, very strong impact, but that was more early summer than late summer. So it's trying to understand why ENSO is different and then how that might change in future to sort of better understand it.
Okay, so Stephanie, I mean, I think that's, I shouldn't say anymore. I'll let the experts speak, actually.
More of a question, just referring back to Dr. Engelbrecht's presentation, also in relation to ENSO. It looks like the Western Cape, there might be a heightened risk in the neutral phase. And I think we often ignore the neutral phase and what's going on there. It looks like there's more heat stress risk in the Western Cape in that period. So maybe just a comment, am I interpreting that correctly?
So I had to go over it in my mind. Those are heat wave days frequency, and the other was the maximum temperature during those heat wave days. Right. That's about the Western Cape. Since we're here. But,
That's how I interpret it as well. Yeah. So difficult really to understand it. I think it's maybe just again showing also, as Ross has just explained, on the complexity of our ENSO response over the various regions. So in terms of prediction, I mean, this is now just an observational study. In terms of prediction, we don't really know anyway. Neutral phases are not really, we can't really say, as the work by Willem has showed over the years. Yeah, we even need to be in an El Nino or La Nina to really say anything prediction-wise. But even observation-wise, it's difficult really to say, except just to interpret it there as directly as we've seen. But I think the higher risk seems more towards the just the interior areas. The coastal areas seems to be less impacted.
So at the bottom line is that we are not neutral to ENSO in the Western Cape. Exactly how it manifests, I think, is less known. Anything? No? Okay, I'm going to move us on. Thanks for that interlude. So we were going to go to groups. It's now, let's check the time. It's now, yeah, let's call it 9:30. I'm going to let you guys go for 3/4 of an hour, and then I'll see how we're doing. Okay, so you know which groups to go to, you know where you belong. So off you go. Thank you.
Another meeting. You're going to attend another meeting.
So those are the questions I posed. Whether they stuck to them or not, you'll find out.
No.
Okay, I'm going to go chase them off.
Okay, well, should we get going? The stragglers will straggle. Neville has given me control of the room. So let's see what happens. Okay, folks, let's just repeat the program that we did yesterday. I'm going to ask if any of the groups is particularly motivated to open their discussion on the questions. And we had some very strong groups keen to present yesterday. I'm sure the same will be true today. And don't be shy. We have a hand. Great. So do I give up the microphone? Oh, it's dangerous.
Lost power already, first 2 minutes. Just to sort of kick off the discussion, so this is Red Team. I didn't take good notes because we were basically having quite an intense discussion about data availability and whether it should be made publicly and what data. So to start off, our sort of consensus was that data shouldn't be made publicly in a sense to anyone can access it. There's various reasons for that. However, the data should be available to various user groups, academics, research groups, etc. But it's okay to have a few protocols in place. For example, having a contact person to make sure that you can get access to the data, and that person will also be able to provide feedback of the sort of guidelines of usage of that data. So there needs to be some things in place before you can actually just go ahead and use data. And then in terms of payments or who should manage or who should fund this, funding was definitely an agreement that Treasury should take responsibility of this. The notion of the private sector contributing was shot down pretty quickly, which was I did find very interesting. And in terms of management, there needs to be some sort of umbrella body that sort of manages the data. How and in what form this takes place, I think we need about a week discussion just on this topic. Data is a real big issue. It's something that we all struggle with. I think from this conference, hopefully there's a new path forward on sharing of data, collaborations. Yeah, it's desperately needed. This has been a discussion that's been happening for decades, and we don't seem any closer. But slowly but surely, progress has been made, and hopefully from this, there'll be a clear path forward. Oh, what was question 2? Was that the reports? They should, one of the things we struggled with was how should the reporting be done, or how should the warnings be done? I think from our notes, it was warning shouldn't be overplayed. It should be done when there is critical knowledge available, then it's disseminated. not days before. It should be a case of depending on who the relevant parties that need that information. So we were very cautious of overwhelming the public. The one aspect was the education of warnings and how to go about that. And I think one of the points which was raised was education at schools, which there's great evidence to show that school kids pick up this and take it home. And it's a great form of communication of teaching people about weather warnings and how to react. Again, this is also a big discussion point is with these warnings, how do you react? What are your options? And then, again, educational behind that is, and sort of giving communities the resources to act as something else. That's a sort of a summary. I think our group could have carried on for a whole afternoon on just these 2 points. It was a really good debate and really good input from everyone.
Fantastic. Yeah, I did hear the comment about involving children in policy more actively, and I just wondered if my son was involved in policy more actively, what the world would look like. But everybody would be online playing games. Okay, you're gonna give us.
So if my son was involved, there would definitely be no exams. So we have the opposite problem to the previous group. I'm from the purple group, and we wrote down literally everything that everybody said. And now I have the challenge. My group said they'd help me during tea to distill the key points, and nobody did that. So, but yeah, very similar discussions, but also very rich discussions in terms of the data. We distinguished 2 types of data. So there's primary data, and then there's kind of products that have been developed. But then there was also missing data, actually, so 3 types. So in terms of the primary data, that needs to be available, the weather data, the basic stuff. And we had some discussion around who pays for that. And someone said subscription fees could be used, and I'll come back to that. The other option was, what if we work from the point of it should be free, and then we work out how we're going to make that happen? And it would be really great if Treasury took responsibility for that. But in the absence of that, we heard yesterday about all the global funding options. And if we have to tap into external funding for a short while to make it happen, maybe we can demonstrate the utility of having a fully functional system. So I think primary data was really important for everyone to have access to. Derived data, I think we kind of agree with what they've said. You can't just put it out to anybody. Again, we have national security people in our group, and they were saying stuff can be misused in unintended ways and have really damaging international consequences. And could data be kind of turned into lost the word, but kind of a weapon of mass destruction. And yeah, so then we spoke about, well, what's missing and what do we need? And we talked about needing hazard information and what's the word for impact information. And we spoke a lot around vulnerability. So you've got the hazard actually happening, the climate event, but then where are the vulnerabilities? And to have that information mapped would be really important. We spoke about a lot of data that is out there but not digitized. So for example, health data. And so there's a role for digitization of data. And then there was all this information that's out there. So for example, state organizations have people apply to do research with their information, and that's all very well. And there's all these products. And do we make those available? The question was, who verifies them? And that's where we came back to this subscription. You would probably need to pay someone to go through that and see, what products have been developed that are useful, that we might want to put forward versus, those that you did your student project and we'll just leave it at that. Yeah, so, and then there was a whole bunch of discussion around why we might want to monetize or not monetize. I won't bore you with that. In terms of the second question, should we report on extremes? The answer was yes, but how? So we used the example of day zero where people were viewed as alarmist, and you can lose trust very easily amongst the public, but it's very difficult to actually regain that trust. And we spoke about trust being a two-way street, and there's a lot that people from the ground up can contribute to this. So you know, if there's a rainfall warning, which are the streets you're going to avoid, which are the problems going to be, and how does one, get that information into the grid? There's a lot of technologies out there. And we spoke about the difference between short-term and long-term predictions, and they have different kind of trajectories of timelines which you would warn people, and different groups of people you would warn. So there's a difference between warning the public and warning the people that need to act, and the differences between when we, would interact with those two groups. And then being able to add a vulnerability layer to these predictions. And we spoke about the education around interpreting the predictions would help a lot with the trust going forward. And I like the idea of the schools.
Well done, good. I think it's interesting to sort of consider the focus switch from what data are needed to what are the vulnerability levels that are likely to be exceeded, or I mean, we know roughly how much heat we can tolerate or how much flooding we can tolerate, but farmers may also know. So to switch the focus from the other side to what are the sort of limits that are kind of red flag ideas, and to get those two lenses to talk to one another. And I think that might help to focus the data suppliers. I think this idea of what should be state funded versus what should be added value and possibly in the private domain is also an interesting one. And I mean, I'm fairly certain that the case has been made through research that it is a no-brainer for the state to fund weather services and make data freely available. That case has been made statistically. And so the notion of having to force weather data services to monetize their data doesn't really make sense, because the feedback comes through benefit to the economy as a whole. But to make that case to a Treasury, I think is hard to do, and I'm sure our colleagues will confirm that. But if we could, it would be really, really useful to get some economists to kind of help us out there. Did either of the two groups or any of the other groups really think about what data are the most valuable in terms of historical, what parameters, what do we have, and how could we improve it? And are we in a bad space, or are we okay? And how much more would be needed? Okay, well, just think about that. Next group.
So I can't see my other colleagues from the Black group. So the data that we said that we need is, for instance, for flood risk, we need very good elevation models. And also for wind modeling, because especially in the Cape Town area, so the winds go completely high wire. And if you have an elevation model with a 1 kilometer resolution or something, then it's just not doing the trick. And so interestingly, so we said, okay, if you have high resolution topographic data, let's say from LiDAR derived, which technically SAON now is able to provide us with, then the next limitation is actually the computational power. Because if we have, let's say, even an elevation model, if you think of wind modeling, If you're using the freely available 30-meter or 90-meter resolution elevation models, then the computational power is not sufficient to actually run these models at this high resolution necessary. So that's also where the wish list for high quality data is related to perhaps and potentially an increased and improved infrastructure, so hardware and software infrastructure. And yeah, access to infrastructure such like the high performance computing center, which apparently is not as easy as it should be. Maybe we just need more of those in the country. Did I forget anything?
Maybe I'll editorialize a little bit on our group. I think the one question, I think we started off with like a laundry list of, we all have our own aspects and what we're interested in. We had a laundry list, like I want this data. You know, I was keen on radar data, LiDAR data, the whole laundry list. But I think what's really needed is like a shift in culture of away from ownership of data and data as a commodity to data as a shared resource. And I think like the one that I thought was quite clever, and from a foreign country, and I won't name the country, but I think you'll all get it, is that, you know, if data is created and funded by taxpayers, then it should be public data. It should be in the public domain. I mean, if South African citizens are funding the creation of data, then it makes sense that we should share this data with our own citizens.
Sorry, also what we discovered is, and what many people are not available of, is that we have a special data infrastructure in South Africa. So we don't have to reinvent it, so we just have to use it. And there is only very little knowledge about this facility, basically, which is supposed to be a data repository for all kinds of special data. And I think weather data are kind of special. Yeah.
Taxpayer funded. Well, taxes don't pay for anything, guys, but we'll have that discussion at lunchtime.
Thank you. I think we took the side point there quite literally. So we try to focus not on weather data at all, or climate data. A couple of points to mention there was firstly around improved reporting on point 1, not point 2. Improved reporting around citizen science. So reporting of weather events that are perhaps not so easy to forecast, like tornadoes, localized lightning events, hailstorms, enabling citizens to report when these events occur and the tracking of these events to better help forecasting in the future. Something we also mentioned, and I think is quite important for the use in early warning systems, is urban and spatial data. So getting a better handle on what urban and spatial data is available to disaster risk management. And this can include things like infrastructure data, where infrastructure might be lacking, data around hospitals or clinics in the area, their ability to handle an increase in cases related to disaster events, and then really being able to just narrow down the locations where the risk is the highest and where the focus should be for these disaster risk management teams in getting the early warnings out. We also thought it would be beneficial to get a sense of previous disaster risk events, looking at data around the cause of death, the cause of damage, and better understanding what that was, to also improve the forecasting and early warning systems going forward. In terms of around who should manage and pay for the data, well, I'll come to the payment now, but I think management, it's having SAWS being the central repository for all the data, as they are the ones who issue the early warning systems, is probably the best solution, but there needs to be better integration between SAWS and other departments like the Department of Health, Department of Labor, and we also mentioned that there should be better integration between the private sector and SAWS around spatial and health data. We mentioned the inclusion of the insurance industry, for example, could be quite beneficial. And then this also opened up the door for potential public-private partnerships in terms of data management, data sharing, and the payment of the data, including the private sector, like the insurance sector, in paying for data, managing the data. And then on the second point, we didn't spend, well, it was a difficult one for us. I think a key point there was around the public perception of the reporting of impact and occurrence. So there needs to be improved education and awareness around interpreting the warnings for what they are. We also spoke a little bit about community level warnings, ensuring that when the warnings are coming out from the Weather Service, it gets to the disaster centers, it gets to the local ward level, and they are able to effectively mobilize the area where the risk is going to be of the highest impact. And then also the feeding of that data back to the disaster risk centers so that they can better determine their resources. We also thought that radio station involvement is quite key here. I think there's a lot of focus around digital media, sharing of these risk events. So it'd probably be best to refer back to radio as a means of sharing.
So this is from the Green Group. And we started with the last question of how we report, and we identified that the early warning systems should be action-oriented, and that shouldn't only come from the South African Weather Services. We should have an integrated approach on it, including multiple stakeholders like the health, the energy sector, agricultural sector, that could inform how we do the messaging of early warning systems, because people understand them differently, and they need to be guided on the actions they are supposed to take, because you can't just expect people to act all the same when they get a warning system. So you should advise them on what certain thresholds associated with what certain actions should be taken. And another thing that was important that we highlighted was that there is a need to use this kind of data that can also account for the vulnerabilities associated with extreme events, so that they can inform our climate resilient infrastructure planning. So we're thinking forward. We don't just want to use this data for responding to the extreme events for now, but we also want this data to inform our future planning, because currently our infrastructure is not climate resilient. It is old, and it is just crashing under these extreme events. So it could inform infrastructure design standards, or we could set them up through that data. And we made examples of what's already happening by South African Weather Services. They are doing the impact-based early warning systems, and they are collaborating with disaster risk management on how they are reporting on extreme events and how they are identifying certain vulnerabilities. And another example that we identified was the National Climate Change Committee, which is led by the National Department of Health. And this committee works with indicators for climate change and health, and how they collect data and identify what metrics to use or to report on to associate the health impacts with climate change is really important. So we need those kind of committees growing and spreading to other sectors. Yeah.
Just a quick comment on early warning systems before I give it back to this highly productive team. It's quite a responsibility to give an early warning. And what if you get it wrong? So who pulls the trigger? And it reminds me of a situation in Italy in the early 2000s when there was an earthquake in a town called Aquila. And the Italian earthquake experts who'd been monitoring this for years failed to give a warning, even though they could see that the risk was rising. And an earthquake happened, and many people got killed, and this beautiful historic town was almost destroyed. Those Italian scientists were jailed for failing to give a warning. But the implications of giving a warning and not having an earthquake would have been to empty the town of all its residents. And the risk of pulling the trigger for them was too high. And we need to think about that as well, the responsibility of early warning. It falls on SAWS. It's a huge responsibility. Who pulls the trigger, who doesn't? And there's an example of people who ended up in jail. I thought it was incredibly unfair, and there were a lot of papers written about how unfair it was, but those scientists did get jailed. So Google that. It's a horrifying story. Anyway, to this.
I think that's a great example. In our essay, I missed two important points, and the one was the role of news, and talking about the radio triggered my memory. So one of the people in our group, and I think we've all had this experience, that news people want to make a story and they want to make it sensational, but there needs to be education to journalists around responsible reporting of weather warnings and an understanding of what they mean. And I think if we want to start anywhere, it's that engagement between SAWS and the media. They just put out these statements and the media use them in whatever capacity they feel like, depending on how many other stories they've got going, which is highly irresponsible. So I think that is a key point for trying to get the balance right in terms of early warning. And then just back on the data, we had a lot of end users who really want beautifully downscaled stuff with metadata and an explanation of how it should be used. But then we've got the scientists producing these products. And what we realized is that there's a couple of issues. The one is that the scientist is asking a very particular question for a particular purpose, and using the information beyond that point is often meaningless. And there are a lot of data limitations that are not easily explainable to users. And so, this leads to kind of two groups that are not meeting. And this really talks to what Bruce was talking about yesterday. And I think state entities lie somewhere in between and have a responsibility maybe of translating what's going on in the research space and taking out or generating things that can be used by end users, and then really being explicit about the limitations of those particular products. And so there's a space that's not 100% properly filled at the moment, somewhere in between these hardcore data people and the people who want to apply and do something about the impacts.
Before you do, it's interesting to note that the one industry that does in South Africa own the full value chain from weather data generation all the way through to impact and communication to its stakeholders is agriculture. So there's several agricultural groups where farmers have got weather stations on their farms. They pay to maintain those weather stations. They supply the data to a center. Those data are synthesized and given back to the farmers in the form of predictions from which they can make their plans. So that shows you that there is a return on investment. It has to be. Otherwise, that industry would not go that route. That's a good example. However, can we ask them to supply all those data that they've paid for into the national network? So we've got some issues that arise because of this. But it's my point that Treasury should be paying for this stuff without question.
Thanks. I just wanted to pull out a couple of threads from the conversation and what I regarded as some important ideas. One is about tailoring warnings which are directed at sectors or the public for which we anticipate they will take actions to protect themselves and do the necessary. The other is the warning to the responders, those that have to react to the impact. And those are quite distinct groups of people. And it's important that we consider how and if the kind of information they need is different. So I think that's one. And the other was, when we speak about the different kinds of data, in my mind, I sort of classify them as two kinds. One is a sort of dynamic time series. So we want to know, you know, for historical analysis and for forecasting and for modeling, we need all of this time series data, and we need sometimes operationally, we need much more dynamic short-term data. So that's one kind. The other is what I've just written down as static data, which we heard about elevation models, we heard about health data, we heard about claims data, for example. And again, that's all existing data sets which don't change too quickly, perhaps, or might change in response to particular events retrospectively. But that's data which is kind of a resource which is required. And the question I'm asking is really, who's going to use that and what are they going to do with it? And so ultimately the question is, totally agreed, we want access to all of the data where we can see how extreme events are impacting or what effect they've had, what effect they might have. We might need elevation, we might need the flood risks, et cetera, et cetera. But the question is, who's using it and in what system, what kind of applications, and who's running that? So really, this speaks to the idea of a strategic approach to preparing the kind of modeling, processing, information generation for extreme events in particular. So those are just two threads. And then the last thing I just wanted to note is that, and I've heard this both in the corridors and in the room here, is obviously for early warning systems, we want one voice, not many voices, because otherwise it gets confusing. Those are my threads.
And, you know, if any group engaged with the National Framework for Climate Services and how it's currently structured and how it could be better structured, I think that's a very productive area to look at, but maybe this group did.
Thanks. And this is not the group. I was a bit of a latecomer this morning. Just on Neville's point of the additional data, I think in my mind, early warning systems is a hazard warning, not an impact warning. And I think the ancillary data that Neville's talking about is when you start talking about the impact assessment, and then you start touching on concepts of vulnerability and pre-existing social vulnerabilities. And I think that there's a large consulting cottage industry, not a cottage industry, around vulnerability indices. And these are primarily based on a variety of socioeconomic factors, housing quality, housing type, and that comes from national databases. I think there might be a use to have that in a more central accessible format, but I think those are two different responses. I don't think the early warning system is a impact warning system. It's a hazard warning system, and the impacts come afterwards. Thank you.
Thanks very much. I was just going to quickly report back from Orange Group. So actually lots of the things that we noted down have already been covered by previous speakers, so I'll try and pull out the stuff that is kind of adding to. In summary, I guess the emphasis of our discussions is really on monitoring the vulnerability aspects, as many of you have commented, and understanding the impacts better and linking science to action and policy. You know, I think it's essential to get more data, or we felt it's essential to get more data to characterize the changing landscape of vulnerability. That's obviously a dynamic system where things can change very rapidly. So to pull out some stuff that is specific that maybe hasn't been talked about so much. We felt there are many links in the chain to create an effective early warning system. There's lots of places you can not complete the chain to its completion. And perhaps we need to learn how to do this effectively by targeting a small number of specific examples where we can learn how to do that. We talked about different user groups need different warnings, and there are different modalities of communication. There's a strong need to educate people as well in, you know, and give them specific kind of instructions of specific actions that we want them to take rather than just a warning of the hazard itself. We noticed that the impacts data is keyed, and then there's a move to impacts-based forecasting. So, okay, so this is probably one that maybe hasn't been talked about, but we felt there's a strong need to understand and attribute past extremes with both positive and negative outcomes. So where impacts were avoided, why were they avoided? because we tend to think about when things go wrong, right? But I think you can learn from both types of event. We feel there needs to be a bridge potentially between the national agencies and researchers so that researchers can alert authorities if knowledge of emergent risks arise through their research. So how do we better, you know, connect intelligence we may have? And I think that's it. I mean, the kind of summary was about it's essential having a pipeline that connects the science information to effective action policy, and very much, yeah, focusing on the latter half. Most of us, or many of us here, are experts on the hazard, but how do we propagate that information through to action and more on the ground? Yeah, thanks.
I said last mile, the interaction between people who need the data and people who provide it. And that is addressed in the NFCS. Yes, I'll come to you now. Just quickly on Byron's point about hazards. Yes, of course, we need the hazard warnings. But remember that in the aftermath of the event, there's a build back period. And that needs to be informed about future risk of that hazard reoccurring, which is non-static. It could be increasing. So you need to build a bridge back to withstand a much more extreme event in future. So I don't think we can just simply divorce the hazard warning from the longer term side of things. But I think that's quite complicated to do. There is an online question from Penny Price, which I'd like to let her do. I think she's been waiting for a while, and then we'll go to your group. Is that okay? Can Penny come online?
Yeah, sure. Thank you very much. Can you hear me?
Yes.
Guy? Yes. Okay, great. Thank you. I just wanted to give feedback from our group because I'm not sure if the online groups have space to feedback, and there was some interesting discussion in our group. Our group was dominated by the fishing sector. So that was quite interesting, and I think it's useful to have that voice in the room. One of the areas of data that was missing, so on the question of what data, was around the macro scale, so looking at the and not at the early warning system as far as weather goes, but looking more on the forecasting kind of prediction, the long-term scale, things like we see in agriculture where we have seasonal forecasts, etc. So looking at that for the marine sector, that there's actually a lot of data that gets collected in the marine sector, and looking offshore as well as onshore, and looking at collating that data. So there's been a lot of talk this morning and yesterday about the ENSO, but not so much about some of the other big macro processes, biophysical sort of marine processes, such as the Indian Ocean Dipole, the Southern Annular Mode, and the interaction between those three big systems. So one of the participants was pointing to how you can access that data in Australia. So there's an Australian website that collates that data and puts things together. But how we in South Africa don't have a portal like that where that sort of data is available. So the idea that actually we need a champion, we identified that there is already something like a possibility within an institution such as SAON, who has the offshore node as well as the onshore node. I mean, the offshore Egagasini as well as the coastal could be a place to look at that and potentially working together with the OSIMS system and looking at how you could bring all of that together. And then looking on the other end of the scale, which has been talked about more this morning, in the other group feedbacks around the early warnings, more around weather hazards, so around the kind of hazards side of things, just stressing the importance of the user groups or people on the ground, and the importance of education around understanding those warnings. So it speaks to that question, Guy, that you raised of, you know, when do you pull the trigger? Do you say it so often that people ignore it? Do you not say it, and the implications of saying it and then it doesn't happen? And how important education is in making people more aware of what the nuance is in those early warnings. I think everything else has more or less been covered. I just wanted to add those to them. Thank you very much.
To work in. I wonder how much how well serviced they are by early warnings. I think 11 deaths recently suffered by the industry, just 4 deaths just this week. This is a high risk industry to be involved in. So switching the lens to that side.
Yes, good morning. I'm not from a group, but I actually work for the South African Weather Service, but I don't work for the data side. Just want to say, no, so I just wanted to make comments about the impact-based forecasting. So just a little bit, so we are a government agency, but we are mandated by 2 different acts. So the one is the South African Act, which actually specify that we are the authoritative voice for issuing warnings. So that's what Neville said, is you only need one warning, one voice. And that is it, that is us, whether you agree or not, that is what we're supposed to be doing. The other one is the National Veld Fire Act. So if you look at high fire risks, we are responsible for the National Fire Danger Rating System. We're actually at the moment currently reviewing it to make sure if it's still relevant, if the index is working. But from the impact-based forecasting, we've been doing it for about 2 years. It was introduced by the World Meteorological Organization. And yes, the hazard is not our problem. It is the impact. And so we have had many workshops with the value chain of the government agencies. And I think we have a very good established relationship and communication chain. But it's mentioned before about the research, and I just want to remind everyone that we are more than just a data center. We are applied scientists and meteorologists as well. The social science is new to us. So just if there are projects that you think, research that's relevant, it is something that we need. One thing that's a major issue at the moment, and we're trying to solve it, is that we need to evaluate our warnings, because we need to report on those to government and to parliament. How do we evaluate those? Because the data coming back to us is not verifiable from an objective. It does not match the hazard. Now, how do you compare? And if you did issue it, how much of the impact was limited because of what we issued or because of the mitigation that was in place before? And we need to distinguish and establish these 2 different things. We have to. So the more information, the more data that we can get, or collaboration, the benefit it is. So we just finished another national, international project. We are busy with other things. As I said, we're reviewing the fire danger index. So there is a lot of things going on, but I think people just get stuck with the data. But there are really responsibilities that we have to do, and we are struggling with some of it. So I just want to say that we are there.
It's a real problem of sort of contamination by prediction. Once you've made a correct prediction, you bring down the risk, and then the correlation between the hazard and the risk goes away. That's quite, it's quite challenging. But I wanted to actually put Bruce on the spot because Bruce, you've been in this international space for a while. And how do you feel South Africa stacks up with regard to its national framework for climate services? In your experience, working with many, many countries and in this international space, how are we doing? Are we way behind the game?
I'll answer that, but I'd like to respond to the comment about SAWS and verification and evaluation quickly, if I may. And that is, from the academic community, collaboration with SAWS has the difficulty of how do we cost or cover our costs as academics. We're not core funded like SAWS staff. And so I think there's a discussion that needs to happen there about the modalities of collaboration with a core funded institution like SAWS versus academics who are not core funded in that respect. So just a comment on that. Internationally, I think there's 2 landscapes about climate services. There's the WMO landscape of climate services, and there's the non-WMO climate landscape. And the non-WMO landscape is complex. It make up of institutions and various organizations, including commercialization of climate services. And so it's a complex landscape, but it's a big landscape. And it stands as something that's much more fluid and, I believe, flexibly responsive to stakeholder needs. And I really don't like the word user, by the way. Stakeholders are peer partners in climate services. It's not a linear supply chain. It's a web of actors. And I think if I can be slightly critical of the WMO framing, at least the historical framing, because I think it's evolving, is it's often cast in a linear supply chain, the experts with the knowledge, and it filters down through various Chinese walls and so on like that, Chinese whispers, whatever the idiom is. But when you go outside of that framing, it's much more operations that recognize it's a web of actors that leapfrog different levels, that jump around. The connectivity is very, very different. And it brings a lot of added value. And I think there's a lot of necessary conversations that need to happen between the WMO framing of climate services and the external framing of climate services. And certainly within WCRP, for those who World Climate Research Program, we're trying to facilitate those conversations. Not trying to own them, but we're trying to facilitate them because there's mutual benefit to be learned from both of them.
Well, we live in an age of unprecedented connectivity. So there's no excuse really for falling into this trap of a linear feedback, right? We have all the available means to make this a much more interactive web. I also want to stimulate or encourage our international guests to give some inputs. Let's see.
Thank you, facilitator and colleagues. I'm not an international speaker. I'm local. I think the contributions that were coming are very interesting. There's one maybe that was highlighted in the blue group, which I believe is the best group. Yeah, just to make sure that you're up. There was an issue that to say we can't then say what other data sets do we need from source without capacitating source. So I think the major point that came there was use of radars and maybe how we invest in that space. There are other capabilities that they cannot provide without the right equipment. So I think that point needs to be driven home. Then there was another point that came to say source is actually facing multiple pressures in terms of its mandate, to say that at times make it want to stray to other areas, maybe that it should not be getting into to raise funds. And we said we need to press the government in a nice way to say the mandate of source is to provide data as a non-profit entity, and the National Treasury, the Parliament, and other arms of government need to understand that we need to fund source like we fund SARS and Stats SA. So we say we need a business case for funding source so that at least then we have got an entity that is going to perform its mandate moving forward and into the future. And I think we can ride on the presidential speech in the State of the Nation this year, where we have realized as a government that we need to put on the forefront the agenda of climate and these data sets. Then there was a point around how do we integrate big data? Because we're in the era of big data. So that big data needs to come, and also source must interface with the sectors to say, if you're agriculture, what other data sets do you need? If you're health, what other data set do you need? And the formats of that data thereof. Then I would conclude by saying there is like half data we're getting from source. If I'm studying hailstorms, for example, I need to know the diameter, maybe, and other specifications that source is not able to provide now. When you read the summary saying like the size of a tennis ball, what does that mean? The size of a chicken egg. There are many chicken eggs. Now, so these are some of the things that are coming. So I'm saying specificities are needed now in terms of the data or the new generation of data we need from source. Thank you, Chair.
Okay, so this community is strongly in support of SAWS's mandate and for it to be fully funded. Yes, there was another input online. Thanks for that, those thoughts.
Mr. Facilitator, are you waiting for me to answer to talk?
Yes.
Hi, my name is Rob Luntman. I'm from a fishing company in INJ in Cape Town. I just wanted to firstly our condolences to the family members and everyone that fishermen that were lost at sea on Friday. It was a very tragic accident, and our condolences with them. Just on your question with regard to the sources of data. We have extreme weather, in the marine environment. We have fairly good means of being alerted to weather or weather systems out at sea. But where I see the lack, or where I see the need for data, is that interpreting the macro climate sort of changes that are happening and the impacts that it might be having on extreme event frequencies, that data is lacking, or the availability of that data is lacking. And I'm talking about what is the effects of ENSOs, IODs, SAMs on current speeds in the Agulhas Current, for example, sea surface temperatures, wave frequencies that might be occurring on the three oceans that converse at the tip of Southern Africa. That kind of data and the interpretation of that data is not in the industry is unable to do that, but so we've got, one is to report on the extreme events, and the other is to report on the probability of what climate change might do to those frequencies of those extreme events. And that data needs to be interpreted by scientists, by the clever people in the room, I suppose. So, and access to that is where I always find, from an industry perspective, we limit it. I go to the Australian Meteorological website to go look at the climate drivers that are affecting Australia, and they used all those macro ENSO, SAM, and the IOD to give their marine and their terrestrial environment people a view. You're right. The agriculture have linked up, and there has been an approach by the likes of SAWS, etc., to come to the fishing industry and say, you've got 2,000 vessels out at sea. How can we collect the data from you? It is a challenge because the boats aren't equipped to transmit data. The accuracy and the clarity would differ depending on what type of equipment you have on board, etc. But I'm sure there are open sources of satellite data, for example, that has been used by scientists in the room to look at that and correlate bottom sea surface temperatures with sea surface temperatures with currents, etc. I mean, I use open source applications like Windy, etc., just to get some idea of what's happening on my coastline. And I think that's where we lack in South Africa, where we have that kind of portal or that kind of application that we can go to get into the marine environment. We do a lot of rainfall and hail and flooding on the coastline, but in the marine sector, the probability why we need it from a fishing perspective is to know, are the fish going to distribute differently this year? Are we going to have an extreme events? This year, and Professor Luntman did a talk quite some time ago about the macro climate things, and he then reiterated those how those three macro events happen. But we need to know from a marine environment how that affects the marine sector and what the probability of it is. We know we probably a drought in Cape Town, right? With the ENSO, a day zero, probably 2027, maybe, if we have a failed winter this year and next year. So, but what does it mean for the marine environment? Are we going to get more southeasterlies, more westerly storms? What are the probabilities of those climatic changes? And that will help the business to to predict and prepare for the long-term outcome. Thank you.
Fantastic input, just reminding us how real this issue is. You know, their lives are at stake here. And what, you know, this gap, a very, very interesting set of gaps that have been identified. You know, we hear about a fire danger index. What other danger indexes or indices need to be developed? This is a very rich area, I think, that we can make input into. Do you understand there's another input online? Yes. Yeah. We only have a couple of minutes left. I'm not going to attempt to summarize this, by the way. We'll do that this afternoon. A person online is, sorry, I can't see the screen. If you can come in. Over.
Hello. Afternoon. Can everybody hear me?
Yes, I can hear you. Sorry, we can hear you. Apologies.
Afternoon. It's Lindy Smith-Addow speaking. I work at the CSIR. My question was around, do we have any good records of historical disaster events, floods, droughts, fires, like a central place where we could say over the last 50 or 60 or how many 100 years, these are the floods that happened, these are the fires that happened, a reliable system that you could go to in the country, and something that we could possibly make spatial also, with reliable coordinates and reliable data and records. Is there something like that? I know SARS is got a CALM, the CALM database, but the CALM has also got his good, positive and negative stuff. And the disaster center, they are getting this kind of information. If somebody can just comment on that, please. Thank you.
And I'm Charlotte McBride from the South African Weather Service. So you're right, we do have the CALM going back, but the CALM, as you know, is collected from newspaper articles. So if nothing's happening in the world, you get lots of weather events. And if Russia's blowing up the Ukraine, you get less weather events. So very dependent on what newspapers you look at. So the South African Weather Service is embarking on the SWID project, linking with disaster management. So we are hoping that CALM, which is in geocode, we do have lats and longs for that CALM. We're hoping with the SWID project that we can get feedback from disaster management. So additional information, not only what's happening on the ground, but the extent of what is happening on the ground, where the actual flooding took place, what bridges were taken out, what roads were taken out. So more detailed impact from your disaster managers on the ground and anyone else who wants to feed into that database. The other idea to take it even further in future years is also to use crowdsourcing. I think somebody mentioned in the room where we get citizen science to report on maybe hail size or tornado footage or something like that. So we're hoping as the Weather Service with our partners to strengthen that database because, as you say, the CALM isn't quite up to standard. So hopefully watch this space. We're working in it.
Thank you.
Okay, I've been told to report quickly from the Pink group. Maybe we will send in all our details, but maybe we could just have that where we turn the data on the head. And it's interesting that everyone is talking about source data and very few people are talking about data in other centers like the ARC or the Water Affairs. We also have weather data. So we were wondering about an idea where the government sets up a environmental national network. So with the SAON data, ARC, because you will see in South Africa, and sometimes you have an ARC network station right next to a weather service station. It's a waste of resources. So why don't the government set up a proper environmentally
sound network that measures all the parameters, pulls in the networks of these various other organs of state, and then has it as a separate department that runs this national network of stations. It capacitates it. It has all the technicians. It has the computers, the ICT behind it. And then that data is available to anyone who needs it. But it is ring-fenced in terms of funding. You're getting less duplication and you're getting quality data. The other idea that we thought about is if that is an option as funding for SAWS or other state entity networks, is have and it was mentioned here, subscription basis, but have a basis where people who want to use the data pay a portion of keeping that data current, keeping the stations up. So you pay a kind of subscription that could vary in different formats, maybe based on the institution, number of papers you're producing, or if you're going to use the data for commercial purposes, you pay a subscription and then you pay a portion of how much money you're going to be generating commercially into keeping this network funded. We were also pointing our finger at international donors and the WMO and saying that maybe they could look at strategic stations across the world, those long-term climate stations, and maybe tapping into funding to keep those stations that are strategically available, and that funding would be available to make sure that those stations don't close. And then we felt that we need more upper air radar and maybe mobile radar, that we can actually move the radar into areas of disaster to get sort of more high resolution data into those areas. And maybe what we could do is invite people like the US to test their equipment in South Africa. And then we could use that data from those testing sites. We were also looking at maybe possibilities of using drones to get more high resolution weather and even data over communities in terms of spatial data. So we have a number of other aspects, but I just thought that that would open up the debate in terms of possible alternatives to funding networks of these nature. Thank you.
Good.
Thanks. I'll just say thank you to all the teams for some really good inputs, and hand over to the maestro.
Thanks, everyone. That's a really helpful and valuable discussion. I just want to, in transition, say that in case you aren't aware, there are some really great databases, open source, available already. Things like the Green Book exist, the SARVA, which SOAN runs. There's the National Climate Change Information System. Again, they all have their strengths and weaknesses, but they exist. OSIMS, which is the coastal one, these all need to be developed, but those platforms are there. And really, the question of making them work better is really necessary. Then I thought I would tell a story, because Guy told a story about early warnings. I have a neighbor, someone who lives in my neighborhood, which really gets under my skin. I'm sure you all have this. It's a neighborhood WhatsApp group, right? We have a WhatsApp group for a road called Baden-Powell Drive, which goes from Stellenbosch to Muizenberg, which we use. And it's a problematic road because it's literally on the beach. And also it's subject to quite a lot of protest action. And so it's often problematic. So she's appointed herself as the sheriff of Baden-Powell Drive and makes it her business to spend all of her time literally messaging about the wind and the waves and whether there's issues and protests, and on and on and on she goes. But the best one of all is when she writes, attention, attention, emergency, emergency, nothing to report, which is what she does. So it's just about early warning systems of no value. Okay, moving on. So the next session will be chaired by Suri, and I'm calling him Suri because I'm not going to even try and pronounce his name. So the first order of business for you to teach us how to pronounce your name, Suri. And as punishment, you have to announce the names of all the South African who have also complex names and answers. Thanks, Suri. Yeah, you start.
Good morning, everyone. As Neville said, it's very difficult to pronounce my name. Better you can call me Suri. It's Surya Narayanan and Sarva Jaya Kesavalu. So since Neville asked, I pronounced my name. Thank you all for joining this session, Risk and Vulnerability on ECE. We have two keynote speakers. Each keynote speaker have 15 minutes of time. So we request on behalf of the organizing team, restrict your time. The first speaker, Johan Stander, on overview of WMO programs on extreme events. Over to the speaker.
One, two, perfect, perfect, thank you. Where's the remote? I've got it, okay. All right, noting that we're starting 10 minutes late, I'll take 10 minutes extra. And as a typical ADHD child, I've probably changed my presentation 100 times. And it's still not what it should be. I made a joke at the first evening at the opening remarks when I said, the best is to adapt your presentation to the audience, but the best is actually not to have a presentation and just talk of bullet points. And that's what I prefer. However, they wanted a presentation. So I decided, okay, let me dig a little bit strategically into what the WMO do, because some of you may not know the WMO and how it can work with you. And number two, then I'll dive in a little bit into some of the areas that I've picked up so far. That's old one. So the first, I think, important is to mention that although we are a scientific organization or specialized agency under the United Nations, the important thing to mention here is that under our convention, it clearly articulates that the WMO plays a role as a global coordinator for member countries, harmonizing and supporting the work done across national meteorological and hydrological services. Therefore, if we say, okay, the WMO is the custodian or the umbrella or the authoritative voice within the UN system about weather, water, climate, and environmental related issues, then it includes everybody in this room. And in saying that, the permanent representative of South Africa to the WMO by default is the head of that particular, or in 99.9% cases, the head of the local national meteorological and or hydrological service. In this case, South African Weather Service. How they work within the country and how they coordinate is up to a national responsibility. We don't get involved in politics at national level. That they've got to sort out. We've heard a lot of things today and yesterday about data and products and services, but they've got to get together and resolve these challenges they may have. This presentation will be available, just by the way. The second one I would like to touch on is that when the WMO went into a typical UN body, you know, we can talk in ages about one paragraph, trust me. You will start in the evening, 8 o'clock, you will finish tonight at 11 o'clock, and 2 member states will still not agree on a specific paragraph. We've moved a little bit away from that when we reformed in 2019 into a more action-orientated, people-centric provision of services. And with this in mind, we had 8 technical commissions. We then moved into 2 technical commissions. Now, the technical commissions within the WMO, they do what I would like to refer, or we would like to refer to as the normative work. Therefore, setting up your technical regulations across the globe, agreed by member states, which they must implement. The same with certain standards, guides, and guidelines across the globe. Therefore, it's agreed internationally. But those guides, guidelines, standards, and technical regulations are developed by experts like yourself in this room. And between yesterday and today, and I'm sorry to say, there's only 2 people currently involved within this group with the WMO. Not only WMO, but through the various groups, the Infrastructure Commission, the Services Commission, the Research Board, the Scientific Advisory Panel, and our Capacity Development Panel. And we should ask ourselves, are we letting South Africa and the continent down? I would like to think so. I'm sorry, I'm still a South African. I will always be a South African. And we should make our voices clear. There's a lot of knowledge, and I would like to encourage you to please participate and put your hand up. And when we did that transformation or restructuring of the technical commissions, we also restructured the secretariat. Oh my goodness. We also restructured the secretariat as from 2020, when I was very fortunate to join them. So we've got a strategic objective looking after services, one after infrastructure. And when we talk about services, we talk about climate, health, energy, UNFCCC, policy, agriculture, food security, even fisheries, the one I heard online, oceans and coasts, aviation, disaster risk reduction, public weather service, impact-based forecasting, catalogue of hazardous events. Charlotte referred to it, where we're going to replace, Mary Jane, the MDOT data to make sure that everybody in the country is using the same data. So it will be something done between the WMO or the Weather Service and the National Disaster Management Center in South Africa to make sure it's up to date for everybody to use the same data. So that when we again provide an atlas on mortality, on economic losses and mortalities, it's done with the right, correct data set. Politicians do not understand figures. They understand visualization of what happened in a specific country. Then we've got our Science and Innovation Group, which I'll come to a little bit in the presentation if the time allows me. Please, you've got to give me, when it's 5 minutes, tell me. Then our member services, so they look after our regional offices, which supports specific regions, and then our smart corporation, that's governance services area. Now, the 5 directors and the Secretary General, Deputy Secretary General, and Assistant Secretary General form the board of the WMO, and the technical people of the Services Department, Infrastructure, and Science and Innovation reports directly to the Deputy Secretary General. Everything that we do are linked into the SDGs. And within the science community, I've been reading the United in Science reports for the last 4 years, and I've hardly seen some papers of South Africans. And the note I made in my book there is to go and ask them, why aren't you looking at Africa? And I can't say South Africa. Why aren't we looking at Africa to add value? So I'm making a promise to you that I would like this to be a more inclusive United in Science, because there's some really good talks today and yesterday, what I've heard, and can really add value into the United in Science, which we publish on an annually basis. Yeah, I already spoke about the SDGs. And then also, we've got no choice. At the UN level, we work with the Paris Agreement, as well as along with the Sundar framework. That's part of our role, not only member states, but also working across UN bodies. We've got a joint office, for example, with the WHO, and UNDRR is in our building. And we've got a center of excellence between us and them. And it really works quite well at a global level. with us, but it's got to filter through into national levels. So I'm just going to quickly touch on some flagship projects. And the most important one was when the United Nations Secretary General Guterres on the 23rd of March 2022 declared that it's an injustice that people are not protected by early warning systems. And he said by the end of 2027, he would like everybody to be protected by early warning systems. And in that announcement on that day, he said, the WMO, you will develop a high-level action plan for us to be considered. And we did it. It was difficult. Trust me. To develop something from a secretariat without member states' involvement and getting all other UN bodies involved was quite challenging. However, we did it. And at the end of the day, it was presented at COP27 at Sharm el-Sheikh, where the parties, and I'm going to include the following, funders, as well as the private sector, all endorsed it. The small change that happened at that particular one is the UNSG said, we would like the WMO and the UNDRR to co-lead the implementation, not own it, co-lead the implementation of the early warnings for all process. And that, colleagues, is extremely important, because what we've heard so far today is there's a breakdown in communication, maybe between disaster management and South African Weather Service and the public at large and the last mile, and then the feedback loop. So we've got to fix that. How we oh my, what's this? Ah, cool. All right. So we developed it and said, okay, it's a people-centric multi-hazard early warning system. For those who know it, people-centric multi-hazard early warning system is based on 4 pillars. Number 1, disaster risk knowledge. UNDRR, that's your responsibility. You drive it. You know the risk. You know the risk areas. But share that information with the other pillars. Number 2, pillar number 2, which is led by the WMO, is mostly your National Meteorological and Hydrological Services. Data. Make data available. I'm not going to say anything about it. Okay. Modeling, products and services, and then ITU, communication. Send that warning in Common Alert Protocol format. Somebody said on your mobile, yes, you will get it on your mobile, but we've got to fix South Africa first. But we're also working with the satellite community, because some cases when there's a disaster, there's no satellite, cell phone coverage. So we're working with the satellite communication. We've got 1 or 2 on board already, but it's not finalized, where when the cell phone tower goes down, you will get it on your mobile through the satellite. And then the last but not least, I4C, last mile, people in the communities. How do we reach them? It's their responsibility. But they all work integrated together as one. And I promise you one. And they meet. On a weekly basis, they meet to discuss implementation at ground level. Part of this process is to look at the initial 30 countries that were selected, and then they go through this mapping. And if I can quickly draw your attention, you will see over there that, I can't even read my own screen in front of me, I need new glasses, that in most countries, there's a serious lack of impact-based forecasting and the understanding of impact-based forecasting. We've heard it today and yesterday about data sharing, infrastructure, and the sustainability of infrastructure in a particular country. It's all those hazards. The early warning system, you can go to the website. It's earlywarningsforall.org. All of this information is publicly, freely available. As we assess the countries, we put it out there for everybody to see. The global indicators, the implementing indicators, as well as the country, a specific country's capacity once we've done it in that country. How do we do that? We had the top-down approach where the UNSG wrote to the presidents of 30 countries, said we would like to start with you, please. And you know how a top-down approach goes. Slow. Then we've got the bottom-up approach, where a country says, I would like to do it, please. And what happened? South Africa said, we would like to improve our early warning services for all. And I abused my position because I'm from South Africa. I said, let's do it. Because they would like to roll this out into Africa. So they've got their national consultative workshop with the resident coordinator of the UN at the week of, I think, 15th of July. And that week, they will get together, or they should get together, everybody that should be involved in the early warnings for all for that particular country. And I'm really looking forward to that particular work. They look at gap analysis across the entire country. In fact, they've got this national consultative stakeholder coordination. They develop a national roadmap. They identify the priority areas, the link and alignment, and the current status of early warnings for all. And all embedded in all of this, we also look at what's the cost to improve it. And then we try to get the funding for it. John spoke a lot about it yesterday. On one aspect, it was as well as soft. We also worked with the Adaptation Fund and GCF, and we tried to get as much funding we can for members to implement. But it's also got to come from top down. So my request, Neville, is maybe from this group, they can ask government to make sure early warnings for all is a national priority. Because once it's a national priority, they will say, we need to pay attention. Because this adds value to your climate action. Climate action is not something separate. Climate action, early warnings for all, adds to, supports climate action. We can't put the two, look at the two separately. I'm not going to talk about cruise. John spoke about it sufficient yesterday. I'm not going to talk about global observing networks. We've heard a lot about it. The only thing that I can say, Charlotte, I loved what you said. You know, it sort of linked to the WMO integrated global observing system, you know, where you look at everything in a country, share the data. And I love the proposal. I think it can work for South Africa. Very good proposal. I'm not going to now talk about SOF. John spoke about it, but just to fill the observation gap, I noted my time. Just want to quickly mention that we've got the greenhouse gas watch. Maybe we can get a little bit more involved here, because it not only looks at what happens at land, but also at sea. And Guy, we spoke about your underwater robots running around. You know, let's get you guys involved in this program, please. We've got the very important one. We heard a lot about hydrology yesterday. Colleagues, there's so much information available readily there for you. We've got the Hydro Hub. We've got the Hydro SOS, Hydrological Status and Outlook System. That's your status of water, you know. And we get all this information from the country, believe it or not, from Water Affairs. We've got everything, it's there. Just, yeah, speak with us, all right? You can look at these slides a little bit later, because there's a lot of detail. One of the other ones, which is also critical for us, is the cryosphere and the downstream effects due to climate change. So it's not only about the melting of the cryosphere, what happens downstream, the flash floods, at the end of the day, sea level rise. So we look at the whole value cycle of the cryosphere. Quickly also on state of climate reports. When I joined, these state of climate reports were thick like this. And as an ADHD, don't give me a thing of 200 pages to read. You've lost me after 10 pages. Said we must make this more visual for people to understand. Let the politicians decide if they understand it or not. But in most cases, they will probably understand a graph better than a paragraph of text. And we moved away from just a lot of text. It's still there for the scientists, into a more visual type of explanation. And from that point onwards, we moved into regional state of climate reports. And I'm helping where we can nationally. And I would like to see national state of climate reports to be released, because that is the driving force for funding, for them to see this is why I need to fund. We also got the state of water report that we now provide on an annual basis. And I say, let's combine everything now. Okay, state of water, state of climate, state of weather, all in one on an annual basis so that the politicians can see where they need to invest. Now I'm talking to everybody because it will affect all of you positively, I hope, if they buy into this. I'm not going to go into what happened last year. Everybody saw these slides about high impact weather. I know my time is almost up, so please go and have a look at our World Weather Research Program and everything they do, how you can collaborate. Bruce, you spoke about our Weather Climate Research Program. I'm not going to say about it, you know probably more than I do, although it's within us. So that's great. Also, we are at the moment transforming our global data producing centers. We've now moved into WMO integrated processing and prediction systems. And within that, we've got a whole roadmap towards 2027 to make sure that we've got new designated centers around the globe. And we've got to work together, everybody to, and also have access to that information. Last but not least, my very last slide, how does this all work? The WMO is not only for Met Services, it's there for the people. We are a UN body, we are public servants, we are there to serve. And it's all in a round circle. So we've got our National Meteorological and Hydrological Service, we've got the member countries, so it's all government and legal on the one side and policy driven. And then the vision on the other side is our linkages and how we work with our stakeholders. We don't only talk to one another. We've got agreements with private sector. It's part of our work. Microsoft and Google. We've got to help members to really form those partnerships in a country with the private sector and the banks. With that, my time is up. I would like to thank you. I could have taken another 2 hours just talking about our work. So thank you for the opportunity.
Thank you, Johan, for the enlightening talk about the WMO initiatives. Thank you for inviting the researchers to involve with the WMO research programs. Thank you. We'll move on to the next session. The next keynote speaker, Babatunde Abiodun and Rose Blamey, on Pan-African and transdisciplinary lens on the margins, tackling the risk and extreme events. Over to you.
Thank you. Can I use this microphone? Is that okay? I'm going to up your hand here of changing a presentation 1,000 times to not seeing a presentation and giving it. The PRs for this project, Babatunde, Ellen, or Wilfried, couldn't be here today, so they asked me to step in and give the presentation. So I apologize in advance for a bit of reading off the slides, because it's not really easy knowing what someone else is trying to think. So we've been invited to give this talk, to give it an overview of a project that's just kicked off related to extremes across Africa. This is going to be an example of where various institutions across the African continent work together to redefine extremes, or what our definitions are of extremes. And I'll give you 1 or 2 case studies in some of the slides. I would say this is not necessarily new science, in a sense that working with stakeholders, working with different research groups for these large projects has been the norm now for a while. But this is just going to be an overview of what's currently taking place for a project that's started, I think, the end of last year, but it's only really kicking off now. What you'll see here is a snapshot of media headlines for the last couple of years. You would think that the amount of destruction, deaths, and whatnot is decades. It's not. It's literally from 2022 when this project was in its proposal phase. This is what sort of stoked the fires of understanding extremes across the African continent. You can see that particularly the last couple of years has been very hard, a lot of loss of life. But also what you'll notice is the array of extreme events that are there. It's from tropical cyclones and flooding to heat waves to extreme drought. So one of the key factors here is sort of getting to grips with extremes across the African continent, and providing sort of community input into defining these extremes. And that's what Palm Trees is about. So just the overview of Palm Trees, we know extreme events are going to be getting worse. For the science is clear on this. The problem is what and how to use the information. So what Palm Trees is doing is it's focusing on a particular type of community, which are those people, which are people on the margins. So if you think of people sitting in informal settlements, those are the people that are being targeted within this project to try and understand how are they impacted by extremes? What sort of information do they get? What is told to them about extremes? And then how do they use it? And at the same time, what you're trying to do is making it African-based so that any information that is used is reported across the different project members. And what we will be using is to try and gather that information and then try and inform policy on that. So it is a large project, and it's got a lot of moving parts, but it's project people, project partners all working together with these communities. The definition of being on the margins has caused a lot of debate. In this case, I think just within the project team during the funding phases, going through the reviews, everyone had different ideas of what being in the margins meant. It wasn't necessarily a social component, not necessarily a financial component. It was gender components too. And so what's the umbrella of this all is trying to incorporate as much as possible within the project, within these communities. So when we go out to do the field work, all of this is considered. And as I say, I think it's been a good year of debate of defining what the margins is. And I still don't have, in my view, as a climate scientist, a clear understanding from the social research team what the margins are. We'll just give you a quick idea of a recent event. So that panel at the top there, what that is showing is where you see the pink color, that is showing since 1981, those grid cells are the driest it's ever been in January and February this year. This is the current El Nino state. So where you see the pinks, it's the driest, second driest, and third driest. An interesting statement was made in the December, I think it was, of that year, saying that the upper catchment for the Kariba Dam, where most of the hydropower is for the region, well, hydropower is produced for the region, that normal to above normal rainfall was forecasted for the year, well, for the upcoming summer, and they had the complete opposite. So we all hear about what's happening in the mines. So you hear about the copper mines being impacted, you hear about maize shortages. What about the communities? What about the communities living in those regions? How are they doing? What are they doing? What do they know about this? So this is what part of our Palm Trees is to actually go out into the projects, go out into these regions and to sit with the communities and better understand how they've been impacted and what they've done about it, and develop sort of climate resilience to these extreme events. So the Palm Trees team is quite broad. There's focusing on 4 different regions, and it's been roughly classified as West Africa, Central, Eastern, and Southern. The polygons, which are brightly shaded, are where the case studies are currently taking place. This is also involved with UK partners. There's also 1 or 2 other European partners involved. And I'll talk more about the individual case studies for what's taking place. But that's just to give you a highlight that it really is African-centered. The only part we're missing out is Northern Africa. There are no project partners for that. So hopefully through proof of concepts, this can be rolled out elsewhere. The focus here for the project is very much on floods, droughts, heat waves. Those are the 3 extremes which attention is being put on from a physical science point of view. So one of the aspects is understanding the drivers behind these extremes. So from the climate science component is a focus on those 3 events. And then one thing is looking at how do they differ across the African continent. When we talk about flood events, it's trying to develop, as we say, these disaster maps across Africa, trying to collate all this information. That is a very lofty goal, but it's sort of starting towards working with these communities to understand, for example, how they're impacted by flooding or drought. One of the things is that I should highlight, the transdisciplinary research approach here. It is working across the board. It's not just climate research and social research. It's got various NGOs involved. It's also working hand in hand with the communities. And it's good because the discussions are robust. Every single point is targeted, highlighted, and until there's a common understanding, we don't move on from any of the discussion points. So meetings do take a long time. At the end of the day, what we're hoping to do is to build this knowledge and use it to inform policy and to feed back into governments, to highlight these communities, highlight the risks that are associated with them. And hopefully by that will result in policy changes. Sort of the impact goals. One of the aspects you're looking at are compound events. So looking at both heat, or sort of like droughts plus floods, and then how the social impacts of those take place. I can't speak more to this. It's a bit out of my field with regards to bringing the social aspects and the physical aspects together, but it's very much needed. It's not looking at these events in isolation. So that is one of the starting impact goals, and trying to see, as I say, how communities are, the risks that they're associated with this. The next thing is to make sure that it is African-wide and to make sure there's a voice spread across all regions. And the idea here is, as I say, pilot studies that will be rolled out onto a much bigger scale once this project is ended. So all the sort of teething issues working with these communities, hopefully once after, I think it's a 3.5-year project, once it is done, that there's a way forward to roll this out to regions that haven't been covered. I think Angola, for example, is one region which is often neglected. There's no stations there. There's no, from a climate point of view, there's very little known about that region. So it's how do we roll out these projects or these sort of pilot studies to regions like that? I'm just going to give you an example from the Southern African component here, just to give you a sort of a flavor of how this is working. So we have 2 sites in South Africa where focus is going to be placed. One's eThekwini at an informal settlement in South Durban. What's going to happen there is the community there will have little eye buttons. They look like little batteries that measure temperature and relative humidity that are going to be placed inside the homes of these communities. And the reason being is, from a climate science point of view, when we talk about heat extremes, we talk about some statistical property or some threshold, 35 degrees, 40 degrees. Well, how hot does it get inside these homes? What happens if 28 degrees is an unbearable temperature threshold that the climate science community has just neglected? To us, it's some property which is easy to calculate. Statistically, there we go, 90% done. What happens if it's not that? So it's living with these communities, and what they'll do is they'll also record voice recordings. And so how temperature or how rainfall, whatever it may have been, how it impacted them that day. So for, I think it'll be 2 or 3 summers, this is what's going to be monitored for this little community. And the team will go out every few months, interact with them, see how things are going. And I think the iButtons is a great way. Now, all projects, all regions will have iButtons somewhere incorporated in it. So this is going to be a great way of monitoring heat stress for each domain. And then the other one that we have is Limpopo. It's a rural community. We're looking at how droughts and floods impact them. So these are small scale farmers, and saying to them, right, you receive early warnings for floods. What do you do? Oh, there's a drought for seasonal forecast. How do you handle it? How do you cope with these extreme impacts? So that's just the Southern African component. And now each region has something similar attached to it. Not necessarily a rural subsistence farming community or an informal settlement. Some are like the East African group that is directly linking in with flood forecasting and droughts, and working with communities there on interacting with the forecasting team. So that's the direct link, whereas the Southern African case doesn't really have the forecasting aspect linked into it. Just to give you an idea, this is a stakeholder map of East Africa, where you're interacting with all the different stakeholders, and the communities have direct interaction with the forecasting teams, with the different government agencies, trying to learn from each other. So they had their inception workshop, I think, last month or month before, and bringing all the stakeholders together, sitting in a room and discussing the way forward here. And this is going to be rolled out to each of the different regions going, well, in the coming months. The one big focal point here is embedding early career researchers into the different cases. So each early career researcher, I think there's 16 PhDs there and thereabouts, and they have a social science and a physical science supervisor or guidance mentor, just so that they have a sort of understanding on both sides of the fence. So we are, and the ECRs, they go out into the field, even if their research project is not, let's say it's a physical science project, they still have to go out into the field and interact with the communities, just so they get a sense of the purpose of what their work is all about. So this has been a heavy focus on the project, is to make sure that ECRs are incorporated from the start. It's just not a bunch of top-level scientists driving the work. ECRs are important in it, and that's something which Palm Trees is very proud of. I'm not going to go through this. We've broken it up into different work packages. This will be available to read through after, but this has been worked through, trying to go from the social science, climate science, embedding it all and developing and how to strengthen and build capacity amongst the communities. As it currently stands, as I said, the inception meetings are happening as we speak. So West Africa has just had theirs. It's got a lot of media attention. It's again a big focal point, making sure that this is widely communicated, highlighting the impact that these communities go through when it comes to extreme events. So both West Africa has just started, and again, lots of media attention are going around this to try and get the sort of energy into the project, into governments now, to show that it is important. Palm trees, it's named because of the resilience of such trees under extreme conditions. That's where the project title came from. This is just what you see in Mozambique with one of the tropical storms that passed recently. I'm happy to answer any sort of questions or have a discussion later if you need more information with regards to this project. But it's exciting. As I say, early days for this project, just starting off. There'd probably be a few issues along the way, but it's needed. And I'm hoping that we benefit the communities for this. Thank you.
Thank you, Ross Blamy, for your impactful study, and congratulations to the Palm Tree team for this community-based initiative. We'll move on to the flash presentations. We have 7 presentations. We try to complete with 5 presentations. Then later, after the lunch, we can go for the other 2 video presentations. I'll call upon the first flash presenter, Lawrence Chapungu.
Thank you. Okay, thank you. Good morning or afternoon, ladies and gentlemen. My name is Lazarus Chapungu from the University of South Africa, in the Exaro Chair of Climate and Sustainability Transitions. Today, my 5-minute talk is on extreme climate events in Southern Africa, and I'm focusing on the trends and impacts between 2008 and 2022. I must highlight, ladies and gentlemen, that the results that I'm going to present now are just a fraction of the results that we have for this study. But I'm sure that I will be able to provide the snippets of what is coming up in this study. So in terms of the methodology, we tried to use a multi-pronged approach in trying to understand what is happening in the Southern African region in terms of the trends of extreme climate events. We used a number of research approaches, including a review of existing scientific literature that is available. We also used quite a number of databases. Of course, in this presentation, I'm saying 3 databases, but we went beyond those 3 databases to include several other databases. So these are just some of the databases that we included. We used the NASA Power, the Internal Displacement Monitoring Center database, as well as the International Monetary Fund Climate Change Dashboard. So there's data there on climate extremes that we analyzed using Excel stats. So basically, we did trend analysis of that data to see the trends that are there, as well as some of the impacts associated with those extreme climate events. I must also indicate that as we were analyzing the data, we were conscious of the fact that extreme climate events and climate disasters are related but distinct concepts. So, but in this analysis, the disasters that we included are also extreme climate events, right? So you would find that in some of our graphs there, we are talking of disasters. These are not disasters as in disasters, but they are disasters as well as extreme climate events, right? So of course, the clear explanation, we make it in the full paper. So as you can see, the trends there, most of the trends are showing a significant increase in the proliferation of extreme climate events. Let me come close, I don't see here. All right, so in terms of events, as you can see in B here, over time, there's a statistically significant increase in extreme climate events. This is covering the whole region. So in terms of impact, we're also looking at specifically, displacements of people. So over time, as you can see, the number of people being displaced by these extreme climate events is actually increasing over time, and the trend is actually statistically, significant, right? Oh, sorry. Okay. So the maps that you see there are trying to show the spatial variability. So our analysis was actually at national level. So you will not be able to see the fine scale, variations in terms of the distribution of extreme climate events, but we're looking at national level, right? So we decided to look at national level so that because we know that the differences there might also be based on national policies, resources, GDP, and other factors that influence the impact of extreme climate events at national level. So as you can see, my map A there is showing impacts that are variable across the region, but based on exposure to climate extremes, right? As you can see that, the red color shows, the red color there, it shows countries that are highly vulnerable to exposure. Those are extremely exposed to extreme events. And the yellow there is showing that are less exposed. So then we also have a map which is showing GDP adjusted vulnerability. As you can see there, that the macroeconomic conditions also, they also contribute to the level of vulnerability to extreme climate events. Then the last one, can you scroll a bit, please, for me? The last one is the composite one, taking all factors into consideration, right? The macroeconomic conditions, the policies, and various other factors that is showing. So we analyzed a total of 8 extreme climate events. But in this presentation, I'm just going to talk about the floods. As you can see, this is the distribution in the Southern African region. As you can see here, Mozambique is highly vulnerable to floods. Then we also have, South Africa, right? There's also there is some notable effects of floods there. So as we did an analysis in terms of the Kruskal-Wallis test, there's a significant difference between countries here in terms of the influence of floods or the proliferation of flood events in the region. So overall, we observed that there is an increasing trend in terms of the frequency and severity of flood events, cyclone events, heat waves, extreme heat, wildfires, as well as droughts in the region as a whole. But there are variations across the region, country-specific variations in terms of the trends there. Then the major, impacts include displacements of communities, and these displacements are also associated with other spillover effects. It's just physical displacement, but there's also social, cultural, and other forms of displacements there. So we do have a lot of spillover impacts associated with this impact. Then increased vulnerability of communities, loss and damage issues, social cultural dislocations like I had already indicated. So this is all I have for today, ladies and gentlemen. Thank you very much.
Thank you. We'll move on to the next presenter, Heidi van Deventer and the others.
This one good on? Hello? Oh, yes, that's the one. Okay, so I'm not Heidi. I'm Ilse Kadzi. We are part of the same research team. I'm from the CSIR, from the Biodiversity and Ecosystem Services Group. And I'll be presenting on South Africa's floods and wildfires and some insights that we got from using the KLM database. So the shift towards more proactive planning and disaster management has increased the need for reliable data on disaster impact. Certainly for us, working in an ecosystem services and trying to come up with adaptation measures for floods and fires, it is important to have good and reliable data. So we wanted to analyze by analyzing historical data, we can gain valuable insights into the patterns, the frequency, and severity of disasters in a region. And the KLM Weather Events Database is the most comprehensive weather-related hazard database that is publicly available in South Africa, and it is produced by the South African Weather Service. So the study investigated the use of KLM weather events data in elucidating the cyclical nature and also the geographic scope of catastrophic flood and wildfire events in South Africa. So we firstly looked at the extreme weather events by year in South Africa, and we found that the most common flood-producing weather events in South Africa is heavy rain. And years with notably high numbers of flood events were 1988, 2006, and 2009, whereas years with relatively low numbers of flood events were 1985, 1986, 2014, and 2015. And whilst there were fluctuations from year to year, there was no clear upward or downward trend in the number of extreme rainfall events. And then we also, okay, let me go down. No. Okay, so the KLM database is also so the record consists out of spatial data as well. So we mapped the spatial data. So you can see extreme rainfall events were recorded across the country with the highest frequency recorded in the main urban centers. And this is a bias in the data. Like it was mentioned earlier, KLM data is derived from newspaper articles. So obviously, bigger towns and cities will be reported on more often than smaller towns and cities. Cyclones were recorded mainly in Limpopo and Mpumalanga and on the KwaZulu-Natal coast. One of the shortcomings of the data was that flood data was recorded like it's point data, and flood extent is much wider, the geographical extent is much higher. So I think it's useful to use it at a national scale to just see like where do floods occur. But as soon as you want to do more localized studies, it becomes more difficult because a flood doesn't just happen in one geographical spot. So it's actually like a whole geographic extent that you need to look at. And then we also looked at wildfires. So wildfires have a more distinct pattern of occurrence, with the most frequent fires recorded in the fynbos areas of the Cape, the grasslands of Mpumalanga, and the fynbos areas of the Southwestern Cape. The wildfire events are generally high in the months of June to September, with high fire frequency recorded in December and January. So this reflects just like the rainfall seasons in South Africa, and also the vegetational differences across the country. So we are not actually done with our analysis. We also, the main part we are doing is looking at the 10 extreme rainfall events in South Africa, like using different sources, papers, and seeing what are the main extreme events, and also coming up with criteria to say exactly what we think an extreme event is, and then looking at the CALEM data and seeing if the CALEM has actually recorded those events. But so overall, the examination of flooding and fire history through a database of weather events proved to be a useful tool in understanding the occurrence of floods and fires in South Africa in terms of seasonality and temporal trends, and also in spatial distribution. Sorry, I didn't go down. But there is, however, a need for more robust data collection. That's what we've all been saying, for classifying the data, for monitoring, and geospatial extent mapping, like I said, particularly for regional events which occur over more extensive geographical areas. Thank you.
The next presenter, Tabi Singh Masula.
May I please use that one? Sorry. Thank you. My name is Tabi Singh Masula. So for the next 5 minutes, I'll be taking you through the paper that I'm writing with my supervisors. So this is actually a paper from a bigger project that was looking at climate change impacts in South African national parks. So yeah, it's just a part of the project. So in this paper, we looked at extreme heat trends and impacts in Savannah National Parks. So we were focusing on Mapungubwe and Kruger National Park. So what we did, we wanted to understand the trends and the impacts. What we did, we actually defined extreme heat as temperatures that are above mean Tmax by 5 degrees Celsius for that region. So we performed a man-candle trend test, and for both parks for the period of 1981 to 2020 for the warmest quarter, which is your December to February. So what we found, what we found, what we found was that in Mapungubwe, the graph that figure number 2 is the graph from Mapungubwe. In Mapungubwe, the trend test the MK trend test indicated that there is an upward trend. However, it was not statistically significant. But in Kruger, we found different results where the trend is actually increasing, and it was statistically significant. So I think the results with Kruger were just confirming what we have in the literature. So what we did next, it was just to, I'm on people's slides now. Yeah, thank you. So I want to talk about figure number 1. What we did next, we performed a Creuss-Wallis test. We wanted to see the differences in the number of days with temperatures above the threshold for both parks. And if you can see from that graph, figure number 1, there were actually no decadal differences of the number of days with temperatures above the threshold. However, the results showed that there were no statistically significant differences. However, if you can check the medians for both Kruger and Mapungubwe National Park, they were actually, here they were fluctuating in Mapungubwe, and here we see an increased trend of the decadal medians. And then I don't want to spend much time on that one because it's actually supporting the literature. I want to move to the method that we actually used. It was to conduct the surveys. We actually had a very long survey that wanted to, understand the perceptions of park employees. Among the questions that we asked, I just picked about two. Literature, some do indicate that the temperatures are increasing and all that, but we wanted to understand the experiences of the people that are on the ground on how these things, how these extreme temperatures impact them. And among the extremes that we had listed, they indicated that extreme heat is the most occurred in the past 5 years. So we were actually conducting interviews with people who have been in the park for the past 5 years. So they indicated that it's actually occurring for the last past 5 years, and also it was deemed to be also impactful climate extreme. And we further conducted interviews, in-depth interviews with your scientists, your conservation managers, your park managers, tourism managers, to also have a bigger picture or understanding of those extreme heat dynamics in the park. And during the interviews, interesting issues actually emerged. There was issues about extreme heat causing visitors to, checking out because it was just unbearable. And there were issues about tourists struggling to sleep because it was just unbearable. And we had issues of increased water demand, wildfires that were actually connected with that were actually connected with those extreme heat. So it's actually a list of the things that, there's actually a whole list of the things that we found from the interviews. But in conclusion, I just want to say it's another thing to report all these changes and the trends or changes in temperatures, but it's another thing when you go to ground, you actually realize that the impact is actually deeper than what we report. I think, yeah, thank you.
Thank you, Dobby Singh. The next presenter, Dr. Girish Sudul.
Hello, everyone. Girish from the University of Technology of Mauritius. However, I'm from the computing department. All the questions, forget about the questions. I'm kidding. Our work focuses on AI. This is what we do in the department. So we want to see how AI could actually predict flash floods in Mauritius. For us, it started in 2008. That was probably the first time we heard the term and, of course, witnessed a flash flood. It was devastating. 15 people lost their lives, officially reported figures. Over 2,000 phone calls to the emergency lines in a very short amount of time. And you know the rest, vehicles damaged, houses, etc., etc. So when you look at the graph there, you'd see the rainfall long-term mean in blue, and some of the specific flash flood events in orange. The 2024 January is not part of the study, but I wanted to put it there. That was just very recent. You can see, that it's way 2 times beyond the long-term mean of rainfall there. What our approach was twofold. We wanted to, number one, get the data, collect the data, using what is known as a wireless sensor network. These are small microcomputers, microcontrollers, processors, which has sensors that can actually sense water flow, water level, humidity in the soil, air temperature, etc., right? So we got this part done, but we tested that in the lab. So eventually we want to have this along rivers. We focused on one specific river over there. And the second part was, of course, to once we have the data to, actually feed that in a machine learning model, a deep learning model. So we didn't have we haven't deployed the sensors, the microcontrollers. So we went to the Mauritius Met Services and the Water Resources Unit, the Hydrology Department. Pretty much, I think, like it is here, it's two different departments. So we had to reconcile the data, the rainfall and the water flow. So we did that, and we created different scenarios, including those flash flood events, and we use that to train a neural network. We heard the term yesterday, an LSTM, a long short-term memory network. However, these networks, the tricky part is actually to configure them so that they can learn the patterns, right? So instead of doing a series of experiments, trial and errors on what parameters we have to get right, we've used an optimization technique. That technique is known as nature-inspired algorithms, right? They are based on, for example, how ant colonies move and find the shortest path to the food. We use the BAT algorithm and the genetic algorithm. So based on that, I have to scroll down. We actually configured our neural network, and the results were interesting. In scenario number 2, so the RNN recurrent neural network using LSTM with genetic algorithm is giving us a root mean squared error of only 0.227. We are very cautious with that. I would say it's a preliminary results, and it's not on the ground, it's in the lab, right? So with that figure, we found that very interesting in the sense that we were able to configure that model, right? So what we did next is on the other figure, we actually built some kind of visualization tool whereby once we have the data, we can fit in the data in this visualization tool, which is going to give us the actual rain level and water flow, and what the model is predicting. And we were actually now costing that. So we had, like 3 hours, 6 hours, and 9 hours, right? We went on, of course, to build a mobile application, which can be used by the community, right? But of course, there has to be, we have a disaster risk management center there. So we need someone to actually put those data out there. So I think basically that's it. Thank you very much.
Is he available? Rowan Naikar.
Good afternoon, everybody. I think I'll try to keep my talk quite brief so that we can deprive Neville from using his budget vuvuzela. Okay, so I think for the benefit of everyone, let me just start off by briefly introducing myself. So my name is Rowan Naikar. I'm a geospatial scientist and postdoctoral researcher from the University of KwaZulu-Natal, working alongside Prof. Oni Mutanga and Prof. John Odindi. Currently, at the moment, my research is looking at flood risk within KwaZulu-Natal. And today I have the pleasure of showcasing some of the preliminary work we did around flood risk analysis approaches. So I think from the diverse range of speakers that we've heard, we've gotten quite a good grasp as to what disaster risk entails and the challenges that this then poses to society and the environment. And arguably, a lot of the extreme climatic events that we are experiencing is attributed in large part to our rapidly changing environment. So as flooding and other disaster incidents starts to intensify, we are now forced to start to rethink things such as our land use planning, our flood mitigation strategies that we implement, our legislation and policy in order to cope with this rapidly changing environment. So in order to inform this and address this issue, and I'll paraphrase the word that Bruce used, we require more robust methods to determine where, to what extent floods will occur, as well as the impact on people, property, and the environment. So, however, flood risk analysis spans across many different disciplines, each with their, unique approaches and data sets that they would implement. So with this in mind, what we did was that we undertook a systematic literature review to just have a sense of, what are the strengths, weaknesses, and potential shifts in doctrine that might occur over, a certain time period. So basically, we applied a PRISMA protocol where we systematically searched different academic databases between the years of 2000 and 2023. We used a variety of keywords and created a variety of Boolean functions. And this netted us a total of, 3,000 articles. So then once we applied our screening and removed duplicates, we then had a total of 144 articles with accessible PDF documents. From this, we then extracted various attribute information, so things relating to, for instance, the temporal and geographical distribution of the research, the specific types of methods applied, the overall accuracy obtained, as well as specific data sets that might have been implemented. So what we found was this. Firstly, in terms of the geographical distribution of the research, that the majority of the research was located in the Northern Hemisphere, specifically in Asia and North America. And interestingly, a lot of this research was conducted at smaller localized scales. Then if we have a look at the temporal distribution of the research, we found that, in terms of flood risk studies, it's really taken off in the last 3 to 4 years with a lot more work that's being done. And if we look at the specific method classes, we see that, analytical and evaluation approaches, as well as statistical and empirical approaches have increased in the last 3 years. Notably, analytical and evaluation approaches has increased almost triple in the last 3 years. Then if we delve a bit further into the specific types of approaches applied, we noted that multi-criteria evaluation approaches in the form of AHP was the most common, followed by GIS-based methods and random forest. Then in terms of accuracies achieved, we found that, interestingly enough, for the statistical people in the room, that extreme gradient boosting performed the best, had the overall best accuracy, followed by random forest. Then if we looked at the specific types of data used, so for exposure-based analysis, we found that topographical, hydrological, rainfall, and land cover variables were the most important. Then if we shift spectrums and look at the vulnerability or sensitivity analysis, we found that things such as population density, age, building attribute information, as well as flood resilience aspects were considered some of the most important for these analysis. Then in terms of limitations, unsurprisingly for analytical and evaluation approaches, there was a general concern over subjectivity and bias, while for the majority of the statistical approaches, it was required that there was a large amount of high quality training data, which was often deemed computationally demanding, especially for larger data sets. So I think as extreme weather events continue to intensify, there's a greater need for a better understanding, or for us to develop a better understanding of global flood risk dynamics, especially if we factor in things like, the rapid land use change that we're experiencing, the rapid rates of urbanization, and then you couple this with the rapidly changing climatic environment, it's becoming, quite daunting. Fortunately, there's some light at the end of the tunnel, because from the literature, we can see that there's an increased and more concerted focus on flood risk in recent years. However, and I guess there's always a but, what we require to deal with this dynamically evolving environment are multifaceted, data-driven approaches that are able to adapt to this dynamic and rapidly evolving environment that we find ourselves in. I think I'll end it there. Thanks.
Thank you, Rowan, for the interesting presentation. Now we are breaking for the lunch. Two more presenters. We are continuing after the post lunch. We have 5 more minutes time. Any quick questions on the sessions we had for five flash presentation as well as 2 keynote presenters? Okay.
Let's leave it there. Okay. Thank you, Suri. Thanks, everybody. So we're going to break now. We'll catch up the time. We're 2 flash talks behind. I just want to remind you, we've got a full afternoon, a busy afternoon. But we have locked the doors so no one can leave because we've bought a lot of wine and a lot of food for this evening's cocktail function, and you can't go home without using the resources we've provided. So we've got the whole afternoon just to take it easy. We'll go at an easy pace. So we'll break now for lunch and we'll call you back in about an hour's time. All right. Thanks very much. People outside eating their 3rd dessert. Okay. And Kanyisa Mbata will take over the chair for now. We have 2 leftover presentations from before tea, and then we have a couple of more sessions, and then we have 1 more breakout group this afternoon for you guys to continue discussion, and then the plenary will be chaired by Nicola Bredenkamp van Wilgen or something. and then we will hang around, and then we'll have a couple of sundowners with a snack after that. So I guess we can play those 2 videos and then you can take over. Yeah? Yeah. Okay, thanks.
Good afternoon, dear participants. My name is Hilka Njaula. I'm a researcher at the University of Namibia, and I'm going to present to you a research framework towards mitigating the impacts of floods in Ohangwena region in Namibia. The Kuvelai-Etosha Basin is a transboundary river basin that has its upper catchment in Angola, and it drains southward to Etosha Pen in Namibia. Downstream in Namibia, as a result of water flow and rain, extreme flood events have increased in frequency and intensity, and this results in significant economic, social, and environmental impacts. In this area, a combination of both rural and urban localities are found, and this area also consists of several administrative centers which serves these rural areas. Within this area, sparsely distributed small communities, villages, and suburban areas are found with a lot of infrastructure currently under development. Ohangwena region has Namibia's highest population, and this factor has elevated this region's vulnerability and sensitivity to this flood phenomenon. It's therefore important to develop capacity and mitigate the diverse and adverse consequences of the flood. This will be done by establishing a set of input knowledge and comprehensive understanding of the impacts that come with these floods. As a result, a systematic review was conducted, and 8 research priority categories are hereby proposed. Under governance, it proposes to develop a transboundary flood risk management strategy, integrate environmental impact, and explore the principle of subsidiarity into managing these floods. Under economics, it proposes to determine economic thresholds for all receptor groups, develop costs and benefits of different adaptation strategies, evaluate the potential flood assurances for the CEB area. Under social category, it proposes to establish coping mechanisms due to community learning and lived experiences, to establish risk-reducing behavior of stakeholder groups, so that they inform behavior-based adaptation. And it also proposes to understand the social capital of the CEB flood receptors. And ecological, it proposes to develop ecosystem-based adaptation paradigms, understand and monitor the flora and fauna of the area, establish ecological resilience of the people, the animal and plants, and also initiate pollution control strategies. Under biological, it proposes a study that conducts the biological impact of flood at immediate, medium, and long-term scales, and also to investigate the role of floods to contaminant bioavailability to the lower CEB area. Under vulnerability, it proposes to conduct environmental equity assessment for the area, develop flood susceptibility index, distinguish social vulnerability from physical vulnerability, and also understand the complexity of vulnerability factors for the area. Under mitigation, it proposes that mitigation plans for avoidance, elimination, reduction, and coping risk are developed. And under adaptation, it proposes that we develop adaptation pathways and understand and adopt adaptation strategies held by these communities. These priorities are presented as perspectives to stimulate discussion for research on Kuvelai and Etosha Basin and helps to focus stakeholder attention towards a solution required. Thank you very much, and I will appreciate your questions on emails and any suggestions. Thank you.
This is an extreme weather event poster presentation discussing implementing plans to mitigate risk of flooding. Risk reduction and mitigation planning always includes data extracted from baseline, geomorphic, ecological, weather, and climatic conditions. Flash floods from unseasonal cloud bursts and long duration mid-latitude cyclones have accelerated soil erosion in the Western Cape. In the semi-desert, approximately 350 kilometers north of Cape Town, the Matsikama sub-district's average rainfall varies from 125 millimeters at the coast to about 435 millimeters an annum on the Gifberg, the northern section of the dry Fynbos Cederberg mountain range. 3 extreme weather events have occurred along this altitudinal gradient within the last 18 months are recorded on this poster. Escarpments enhance the formation of clouds, resulting in a combination of juxtaposed temperatures and pressures that, exacerbated by extreme climatic events, result in increased frequency of high-intensity short-duration thunder showers. If we look at figure 1, you'll see that at Sout River Mont at the coast, 40 millimeters fell within 20 minutes, and that caused quite a bit of soil erosion. That was in December. In February the next year, we had over 50 millimeters falling in 40 minutes. And that caused even more soil erosion because the farmer was unprepared and just eaten, his stock had eaten the last of the palatable herbs from the surrounding area, and the soil was exposed. Just keep reading what I've written at the top there. So at the Sout River on the coast, and also at the Mazkambal, if you're looking at figure 1 again, the base of the Gifberg, approximately 115% of the total summer precipitation fell in one single short duration, a high intensity event. Those of us exposed to the raw elements are cognizant of the recent intensification of winter cyclones over the Western Cape. Several temperate cyclones in 2023 resulted in river catchments receiving 1 in 30-year deluges. So if we look again at figure 1, you'll see that above the Olifants River, which is that photograph there, this event occurred where a cyclone moved over in just 2 days, it had dropped more than 240 millimeters of rain. And that flooded those vineyards, which shouldn't be in that riparian zone. That is a riparian zone. And we don't know how much soil was lost there, but we did lose soil there, and we're losing soil in every flood that has happened. We look now at the pertinent results from those studies. You'll see that in the Hottentots, Hollands Mountains, above Waterskloof Dam, is where some terrible landslides occurred after September 2023. A cyclone passed by, and that's a loss of over 7 hill slope wetlands that we can just see from the naked eye there. That is in front of you. You can see the fynbos, and that dark green just above the first band of rocks is alien vegetation. Now, the alien vegetation is a problem because the roots are not able to hold onto the soil when it is waterlogged. So that's why needs to be more effort put into removing alien plants from areas where the water is holding the soil is holding the water for longer times in the mesic fynbos. So we found that wetland boundary zones have extended outwards from floods. Farmers need to reserve riparian and wetland zones for the indigenous biodiversity. And wetland delineations of the 1 in 200-year flood level should be compared to the land use zonations after 1 in 30-year floods. So you all probably read now the main conclusions. And what I want to reiterate is that farmers should be seen as stewards of the biodiversity and ecosystem health. If they are not seen as that, then this country has to seriously reconsider who the farmers have become. Because we have to implement a non-monetary reward system that is meaningful for farmers and their children to comply with. And that means a return or an advancement of risk reduction from flooding. And it has to happen across all departments in the government and includes the private sector. So what we are reiterating that the government should start implementing ecological economics at the sub-district level under the guidance of qualified and recognized geographers and ecologists.
Thank you. Okay. Okay, now we jump into the afternoon session. Our first talk will be a keynote for approximately 15 minutes. It will be Godwell Namo. And of course, I'm timing everyone. Remember, I was also a speaker here. I was timed. I'm very strict. Yes. Okay. Why are you strict? Yeah. You can't just be strict for no reason. Am I being heard? Now, the first thing is I need to know how I'm going to be moved. Okay, that's fine. At least I have got the power to move my own slides. I don't like this next thing. Next. Right. Allow me just 1 minute from my time to just thank the organizers for allowing me this opportunity, leading to a joke that when somebody thought a mic was this opportunity, because everybody's kept on this opportunity and they're holding a mic. I want to thank the presentation from WMO. I think there were quite a lot of insights that came from there. Then there was a presentation from Palm Trees. I think that was a good presentation in terms of what they're experimenting. Some of the slides there, they flighted. One from Kenya, those cattle, they died while they were awaiting slaughter. So the government was destocking. And then as the cattle were in the destocking area, they died because of the 2009 drought. Then when you go to Tanzania in Manyara district, cattle were going for $5 each. And you can imagine who was benefiting. It can't be the community. And the Matokes, hailstorm in Uganda, I think 2011-12, the fields, the Matokes bananas, they were left flat. These are actually the issues that we are dealing with today. When you go to copper in Zimbabwe, the settlements went to the ocean. When I say settlements, I mean settlements and their contents. The contents, they were human beings. So about 2,000 millimeters of rainfall received in 48 hours. No wonder why the mountains gave up and whatever was along the way was swept. This is actually what we are dealing with. So for me, climate change is not just an issue, it's an ethics issue. So we have gone beyond politics of climate change into ethics. What do you say as an individual when addressing climate change? Are you just talking or are you actually having the feel of what you need to do? So this is actually the epoch we are in this juncture. So I think, thank you for organizing this. It's gonna help a lot of people. This is the first time I'm doing a keynote. I don't see my computer here. Where is it? Because no, I wanted to, okay, because now I have to move that. Okay, that's fine, but I'm not going to not be facing people now. That's fine. So what is happening here is this is the first time I'm giving a keynote and we are 3. I don't know how we did it, but it's fine. Trends and impacts of climate change, induced extremes in South Africa, 1920 to 2023, a review triggered by the Climate Change Response Fund announced by the President of South Africa. Now, this is not like I know people are in a campaign season. I'm not going to include the face of the president here to campaign for ANC. I'm including the face of the president because of what he has proclaimed. So that is a disclaimer there. So don't worry when you see the face of the president, say, hey, that Professor Namo was campaigning for ANC. So typically, we do an introduction and background, aim and objectives of the research, methodology, study area, key findings, and conclusions, if you've got time. Now, what is happening here is this thing ever going to disappear? Is this thing ever going to end? This is actually probably the greatest question in everybody's mind. And of course, for those that have come across the literature on climate change, the answer is an unequivocal no. Climate change is here to stay. So whatever you might be thinking of, think otherwise if you think this thing is going to end. So if climate change is not going to change, it means we need then to learn to live with the changing climate. Otherwise, we're going to be transformed by the changing environments. So time has come for us then to talk about this. I see in the talks, nobody spoke about maladaptation. It's a big story. So in the process of adjusting to climate change, we may actually end up getting into the maladaptation space or spaces of engagement. So what it means there is, in the process of you erecting a flood barrier, then that flood barrier resulting in the retention of flood waters, causing more damage than what you intended to do. Remember, you intended to block the flood. Then you end up having what? More floods because you have wrongfully erected a flood barrier. Now, realizing this challenge, the president of South Africa made a proclamation to address climate change and weather-induced extremes during our State of the Nation address on 8 February 2020. What did the president say? The president said to address the persistent. Now, persistent means this thing, it's like a mosquito. A mosquito, it will persistently come to you until a big man like me wakes up in the middle of the night and try to find maybe some doom somewhere so that we can have peace. So climate change has been persistent in our generation to the end. It says address the persistent effects of global warming. Of course, the president does not know that global warming leads to climate change. So the full statement is global warming that leads to climate change, which manifest themselves through persistent floods, fires, and droughts, we have decided as a country to establish a climate change response fund. So this then triggers our research to say, what have been the trends and impacts of climate change and extreme weather events? So this is actually what we are trying to address there. Number one, to establish the trends and pattern of climate change and weather-induced extremes in the country. Then, of course, we were also interested in picking the hotspots that, like, we need to see where are these things taking place. Then you can pick those hotspots to determine the impacts and responses thereof associated with the climate change and the weather-induced events in South Africa. Now, I think there was an issue. Remember in the morning I was saying biomes. When you say biomes, there is no change. So our location map is simply, we were deliberate with my co-authors, which are two of my postdoc fellows, to say, because the biomes are ignored in most of the times in terms of the changing environment, let's actually in our locality map include the biomes of South Africa. So if you do not know, we have got those biomes in South Africa, and this is actually our study area. We generated this one. Now, in the methods there, we use, of course, the calendar. I think the weaknesses and advantages have been said. I want to say to people from SOAS, thank you very much. For me, a defective car is better than no car. So there's a lot of work that is coming from SOAS that we need to acknowledge as academics and also as policymakers. So thank you very much. We use this data, even if it is defective, because it gives us a platform to refine it. And I think where we are going, we then need to refine that platform. The international disasters, EMDAT is one of the sources. And of course, we use ExcelStat, GIS mapping. In my team, we've got that capabilities. Now, the other issue that I'm not going to talk a lot about in this conference, my team is opening up loss and damage because it comes at the tail end of extreme weather events. Why? Because I'm sitting in UNFCCC loss and damage group, working experts group. So there's a lot there. We are even also mainstreaming through DFFE to try and work through the loss and damage issues. Now, this actually is an interesting map that we have put all the disasters that have come from 1920 to 2023 December. This mono map just shows us the spread of the disasters across the country. And actually, you can easily try to start mapping the hotspots that is coming. Gauteng there, we've got KwaZulu-Natal, Western Cape, a bit there in Limpopo, Mpumalanga. And of course, when you move forward, in terms of that, this map then gives us what nature of disasters are those. So if you're interested then in seeing where it's extreme rainfall, drought, field fires, floods, sea waves, hailstorm, heat wave, tornadoes, lightning, then you can actually have this visualization in terms of what has been happening in our country since those decades. Then, of course, there are also interesting issues that are coming from when you're teasing the data there in terms of across the provinces. So you discover the Western Cape, KZN, and Gauteng. They actually quite a lot of these events that are happening. And of course, the floods, they are always outstanding in terms of what is happening. So as you are going to be moving forward as a country, it's around floods, it's around, of course, they're coming from tornadoes, heavy rainfall, all that kind of stuff, and other storms. But also issues of fires are things that are affecting us as a country. In our presentation, we've been deliberate to just keep it at a national level because there's also other work that is coming in terms of the specific disasters, looking at trends, floods, wildfires, tornadoes, hailstorms. This is the work that we're also in the making. Now, when we did statistical text there, you discover that there has been actually a significant increase in terms of trends. No wonder why our president says there has been actually a persistent challenge. So the challenge, you see where it is coming from, and you see the steepness of where we are going. So it's guaranteed. For Christians, this is not rocket science. The Bible says the disasters are going to increase. So I don't even know what we are doing here. Why? Because disasters are going to increase. There's no magic around that. I say it for Christians. If you're not a Christian, for scientists, disasters are increasing. So now we use triangulation. So if triangulated, the Bible says disasters are going to increase full stop. Then, of course, you guys will scratch your heads and say, okay, after this analysis, disasters are going to increase. But the truth of the matter, disasters are increasing. And also in terms of intensity and frequency. And let's educate the engineers. There is no time for you to waste talking about 100-year flood cycle. What year flood cycle? No, there's no need. Because from my geography in grade 5, I was told climate is an average of weathers. You typically measured between 10 to 15, 15 to 20, 25 years. So what it means, we only had one cycle of climate change. When you count from year 1 to year 20, after year 20, every second the climate is changing. So don't waste time saying 100-year cycle, because that 100-year cycle can come now, it can come next week, it can come next month, and it can come in 2 days. So by the end of the day, we are saying all we need then is to be climate-wise and move with what is happening in our country. Now, these are some of the issues. I think I'll skip this slide. You can read it maybe in the paper if it's going to be reviewed by the review gods and accepted for publication. But I think let me move slightly to the impacts. Now, when I'm talking about the impacts, I know a human mind remembers last year's event. But these events have taken place from time immemorial. And one of the events, no, I'm not Afrikaans speaking, Neville. What is the name of this city? Okay, who can read that city? Yes, it's here in Cape Town. So actually, this is one of the floods that has been recorded in history. And during that time, this 1981, there were actually a lot of people who died during that time. And I think it was bad. Why it should have been bad? By that time, the density of settlements was less. So you can imagine now, which is also a recommendation I'll make, is academics need to bring back the population environment debate. So one of the issues that we've missed as academics, during my time in school, we're talking a lot around population environment debate, and that is fizzled out. So if we remove the population environment debate, then the issues of density and vulnerability are also at a superficial level. So the nature of the impact is a function of what is on the ground. If a hailstorm is going to hit Gauteng, of course, you're going to have cars parked here and there. But if a hailstorm is going to hit Northwest or Cape Winelands, then it's going to be a disaster. So it's a function of what is on the ground. Population density, land use, and every other things. So we need to do that. And by the way, by the way, I hear a lot of people talking about mitigation, wanting to say intervention. Because we are climate change experts, please let us be careful about using the word mitigation. In climate change, mitigation means something different. You can't talk about climate mitigation and talk about floods. Okay, that's fine. I said it's a by the way. So most fresh there, we've got KZN. We've got also the 2017 national floods, fires, severe drought episodes. I think they were mentioned earlier on. And those actually, most of them have happened in my lifetime. So I exactly know how the 1990, 91, 92 drought was. We plowed, we never planted. That's how bad it was. 1984, 85, 86, there are a lot. We plowed, we never planted. So these are severe droughts. When you go 2014, 16, 15 in Kruger National Park, there was a severe drought there. Then when you move further up in West Africa, we've got now locusts swarming because of the changing climate. So we have actually in Nairobi experiencing the issues of malaria. Even in South Africa, we are seeing malaria bands moving. So when I talk about climate change, like I'm saying, this is a matter of life and death, and we need to act and act yesterday. Extreme temperatures, cold, 2007, I think you remember, there was a 3-day block in N3. N3, for those that are outside, like my friend from India, it's a highway that links the hinterland to Durban, one of our coast. Of course, it's chaotic now. Nobody's going to send their ship to where to be offloaded after 3 months. Forget it. So we have also lost business, not because of climate change, but because of the chaos on the port. But there was business lost in 2007. I remember a photograph from one of the journalists, and the whole, I think there was a blockage around N3. For 3 days, we could not pass. And the unfortunate thing, remember, we're not in Europe. So we don't have these trucks that scoop snow out of the road. Remember? So actually, as an adaptation measure, if the gods of climate change are going to go the direction of snow and roads, we need then to have municipalities start thinking about investing in those trucks. Unfortunately, you invest in the truck, then the next event is going to come after 100 years. Then you're going to be fired for wasteful expenditure. But it's something that you do there. Right. EM-DET, we're also talking about from now we use 2000 to 2023 data. EM-DET is saying data before 2000 is not reliable. So I advise as a scientist not to use it. So we use 2000, and it's saying therefore South Africa, there were about 1,736 deaths reported across these extreme events, 1,568 injuries, 31.5 million affected. Now, the million there is brought by, I think, 4 drought events. There was one drought event that was bad. So we are saying there, this is something that is coming together. Altogether, about 31.4 million people were affected by these climate and weather extremes. And of course, there was up to about US 9.18 billion in damages, of which this is actually where the crux is. Only 2.67 billion was insured. So there's a lot of uninsured loss. And unfortunately, in the country, especially in the transport sector, we don't have third-party insurance. In other countries, we've got third-party. In South Africa, you can drive your car freely and hit me. Nobody cares. Now, in conclusion, extreme evidence confirmed the worry from many sections of society in South Africa and globally that climate change, whether climate change induced extremes, have been on the rise, and intervention measures are needed like yesterday. In the context of resource constraints to address climate-induced loss and damage, hazard prioritization is needed with a focus on the most frequent and danger-inflicting hazards such as floods and strong winds, especially that we are this side. Strong winds, I've seen cars being blown over here by gale force winds. And lastly, there, more resources can be dedicated for research into solutions that are most for the most frequent hazard. And as the academia and policymakers, we need to shift from the question, from answering the research question, how does it look like? What does it look like? Into how do we address it? So we are now moving to what we call solutions-oriented research. So without solution-oriented research, we are going to be obsolete, and we are going to be getting our PhDs and being promoted to useless professors.
Thank you. Thank you. Okay, thank you for the keynote speaker. Now we will go to the flash. 5 minutes. 5 minutes. Okay, our next speaker now is Maria Cotto. Again, 5 minutes.
Good afternoon, everybody. Thank you for this opportunity. I'm going to give you a brief overview on how Eskom is building resilience and integrating adaptation into our business chain. And by that, I mean our generation, our transmission, and our distribution areas. So just to give you sort of a sense of our footprint, we have 30 power stations, about 33,000 kilometers of transmission lines, and about 360,000 distribution and reticulation lines. So from a geographical spread, our footprint is huge and we are exposed to a wide range of climate hazards. So in terms of climate change mitigation, we know we need to diversify energy sources, we need to improve our efficiencies, we need to look at new technologies, but we also recognize the need for and the urgency of building resilience and our adaptive capacity into our operations. So how are we doing this? We've been actively building up our capacity through education and awareness programs within our different divisions. And that's across the different disciplines. Particularly, we're trying our engineering friends, trying to bring home the messages of mitigation and building in adaptation and design measures based on the climate science. From a research perspective, we've been actively involved and we've had a long-standing relationship with our colleagues at the CSIR. They've been instrumental in helping us understand the climate science, the projections, modeling, the various hazards in terms of our spatial distribution of our assets, and downscaling that to our local level. So they've been very patient with us. Thanks, Mohau, for all the work. So when we look at these climate hazards and the severity and frequency, we need to look at what is the impact on our systems and our operations, our different assets and infrastructure, but also on our supply chain as well as our workforce. And we've been doing this, so we're taking all this information and developing adaptation plans for the different divisions. So each division has got some of them are a little bit more advanced than the others in terms of process, but they have their adaptation plans so that we have a sort of a top-down approach where we can have a view of the climate hazards that are impacting on that division. But obviously from a bottom-up approach at site level, we are looking at complementing these plans with looking at exposure of specific assets, looking at risks and vulnerabilities, and then building in measures to respond. In some areas, there may already be actions that we are implementing. Other areas, there may be actions that need to be implemented, or risks that we just need to tolerate. Sometimes we just won't be able to do anything about it. So when we look at the risks of or all these risks, we implementing them through our existing risk management processes. We don't want to have separate processes to deal with all of this, so we're integrating it into the risk management processes, into our future long-term plans where we're looking at new infrastructure or adaptation plans. And particularly in our transmission, where we're looking at building new lines to support the renewables integration. We're looking at new designs, whether new designs are needed. We all saw the pictures that SAWS put out yesterday of the towers that have been blown over, towers that have been washed away. What do we need to do differently with new infrastructure? So, and also building these into our maintenance regimes, as well as our disaster response, emergency and response and recovery strategies, so that we move from a reactive to a proactive approach. So just in terms of a ranking of climate disasters, climate and environmental disasters, for Eskom, it's really a priority 2 disaster, but with quite a real potential to lead to a priority 1 disaster. And essentially a priority 1 disaster is a national blackout or a severe supply constraint. So these are the type of things that we are dealing with. Yes, so just in conclusion, I think through all the integration of our processes, through our continued collaborations with academia, trying to bring the climate science home, through our governance processes and our stakeholder engagements, we're hoping we're moving in the direction of being able to make more informed decisions and funnel our efforts in the correct direction and prioritize our funding and investments. So yeah, it's a journey that we're on, and it's a process. We're not there yet, but we are building the capacity in this area. Thank you.
Thank you. Thank you very much. Eskom, I think it is always nice to have you guys here as well. And our next flash talk will come from Lindy Smith.
Good afternoon, everyone.
Lindy Smith, hello.
Yeah,
Hello.
Lindy couldn't make it.
Oh,
Lindy,
you are who?
So
Okay, no problem. Thank you.
presenting. Yes, I'll just- Yes, 5 minutes. Okay, so are we presenting on flood hazards in a changing world, the challenges and opportunities in the Garden Route, South Africa. We use that as a study, a case study. So we used historic and desktop data to identify flood hazards in the Garden Route in South Africa. So it involved modeling, doing some flood modeling, and also using historical measure data from we used rainfall records, and we also used discharge data. So for the flood modeling, we used the Sensitive Catchment Integrated Modeling and Analysis Platform, SciMap. And then we used historical rainfall and stream flow changes in the Wilderness River catchment. So we looked at it both on a district level. I don't think we have to go down. Okay. We looked at it both on a district level, and then we zoomed into the catchment level. So the model output showed very high, medium to high flood hazards along the Langeberg Mountains. And in the Klein Karoo catchments of Oudtshoorn and Calitzdorp, and there was also high flood hazard zones along the Touws River and tributaries of the Duiven River in the Wilderness Lakes. So this area commonly experiences floods. It's very small, steep catchments. So when there's high intensity rainfall over a short period of time, you tend to see flash flooding. So those areas were highlighted in the model, and then we looked at historical rainfall data. And so in the wilderness area, there was extremely wet rainfall years. It occurred every 10 years. So an example is in 1981. I wonder if she added. Okay, it's very small, you can't really see. And there was also high magnitude flows that occurred twice in the decade where the flood events was more than 419 cumecs, and this was in 1981. And so that occurred once in every 100 years. So there was concurrence between the rainfall records, the stream flow records, and the flood data. And this area is subject to regular floods. And so it's related to severe weather, the land use change, but like I said, also just the landscape characteristics, and also alien plant invasion. Ooh. Okay, I'm now out of the. Is escape. Escape. Okay, flooding also caused channel morphological changes, but in conclusion, the challenges include a decline in hydrological monitoring data. There's just, we were actually able to use for the wilderness area, there was actually good discharge data, there was good rainfall records, but in general, there's a lack of or a decline in good quality hydrological monitoring data, lack of funding, and it was also future climate change is a challenge. But opportunities include a reduction in hazards through appropriate management and using ecosystem-based adaptation and active citizenship. But obviously, we need the data in order to come up with the adaptation strategies and the ecosystem-based adaptations. So, thank you.
Thank you. That was fast. Okay, our next talk, I'm always happy when I hear hydrology because I think we need them also, hydrologists, yes. And our next talk is by Charlene. Charlene. Yes, Charlene.
Good afternoon, everyone. Yesterday I spoke about cold temperatures, and today we're going to be looking at heat-related health impacts on primary school children. And we looked at measured and estimated risk in Gauteng, South Africa. These results were part of an objective of a larger PhD study, which was supervised by Professor Carity Wright and Professor Joyce Shirinder. The main aim of the study was basically to describe classroom thermal conditions and understand possible impacts on school children's health. We basically our sample size consisted of 904 school children in 23 schools in Gauteng. And we used 3 types of data collection tools. One was a heat health related symptom questionnaire, where each student filled in a heat related questionnaire that if they had any symptoms on an hourly basis whilst they spent time inside classrooms. We also looked at source data for these results, where we calculated apparent temperature. Apparent temperature was developed by Robert Stedman, where we factor in humidity with temperature to see the real feel of exactly what an individual is experiencing at that given point in time. This map, basically figure 1, shows you exactly the 23 schools that I spoke about and where they were located in Gauteng. We tried to incorporate all the different municipalities within Gauteng. The second one gives you an idea of the equation that I was talking about regarding apparent temperature. And those were the results obtained after we calculated apparent temperature on the 23 primary schools. Okay. After calculating the results, we then used a scale with 4 alarm categories. Basically, on this diagram, you can see the caution category, extreme caution, danger, and extreme danger. There's also a normal category. So apparent temperature in the normal category would mean that there's no associated health impact or health effects. In the caution category, you would experience fatigue. In the extreme caution and danger category, you would experience heat effects such as heat cramps, heat exhaustion, and a possibility of a heat stroke. And the extreme danger category would mean that that individual is likely to experience a heat stroke or fatality. According to our study results, most of the actual findings were between the caution and extreme caution category, and we had a few cases of danger category, those that had those calculations that falls within the danger category. According to our heat health related symptom questionnaire, we found that school children suffered from tiredness, feeling thirsty, poor attention, and feeling sleepy. Those were the most common symptoms. The least common symptom was found to be dizziness. What we do recommend is that a better classroom design, a development of a heat health guidelines for school. There currently isn't one. So a development of something like that for schools would be excellent. So they would know exactly how to measure high temperatures in schools. We currently do not have one in our country. We also don't have a recommended temperature for school children. So we rely on temperatures that we use, for example, from ASHRAE, the American Society for Heating and Refrigeration and Air Conditioning Engineers. That is recommendations for adults in office settings. And we use that to compare it to school children. So obviously kids are different from adults and their developmental characteristics, etc., differ a lot. So hopefully that would be taken into consideration in the near future. Thank you.
Thank you. Thank you. Thank you very much for that interesting talk, especially about our classrooms. Yes, And then our next flash will be remote. It is by Anika Maniram. I think it's a special one. This one, it's talking about Umsinga, KwaZulu-Natal.
Hello everyone, my name is Anika Maniram and I'm from the University of KwaZulu-Natal. My topic is the impacts of drought on rural communities in Msinga, KwaZulu-Natal, South Africa. Drought is a period of below average rainfall which results in drier than normal conditions. The changing climates will lead to an increase in drought, with scientists reporting that the past 5 years have been the hottest this century, with global air temperatures increasing by 3 degrees Celsius. There are 4 different kinds of droughts, which are permanent, seasonal, unpredictable, and invisible, and 4 different categories, which are meteorological, hydrological, agricultural, and socioeconomic drought. According to the World Health Organization, 1.5 billion people have been directly impacted by drought this century, while every year an estimated 55 million people are affected each year. According to the South African Weather Services, the Msinga municipality is susceptible to drought conditions, with the area being subjected to high rates of soil erosion, low carrying capacity, and water shortages. Droughts occur at a slow rate, which makes it difficult to detect and resulting in social, environmental, and economic impacts. The results: frequency of drought over the last 10 years. Since the 1970s, there has been a drying trend around the world, with an increase in drought frequency as a result of climate change. It was also noticed that the frequency of drought has increased from every 10 years to every 5 years. Msinga communities have witnessed drought intervals of 2 years, with 2004 to 2006 being the worst in living memory. Adaptations of strategies of drought included selling of livestock by farmers, rural-urban migration, cutting down food intake, planting drought-resistant crops, and indigenous knowledge practices. The severity of drought within Msinga was measured by small-scale farmers through seasonal farm employment, loss of livestock, increase in diseases, threatened livelihoods, and mass migration. The seriousness of drought is also measured by how people perceive it and how they are affected by it. The socioeconomic impacts of drought. Drought affects the failure of crops, since majority of crops in South Africa are rain-fed, increased levels of poverty and unemployment as a result of drought, and poor productivity affects Msinga through the loss of livelihoods. Drought, food shortages, and increased food prices have resulted in limited food choices and food insecurity. Decreased water supplies and droughts have increased malnutrition levels. The methodology: the Msinga municipality is one of 4 municipalities in the Izimania district, and it is located in rural KwaZulu-Natal, with 69% of land being used for traditional farming. For the purpose of the study, archival data was used, as well as a quantitative research method, which is a process of collecting and analyzing numerical data. A questionnaire was used, and a purpose sampling method, which is when the reader uses their own judgment to choose the respondent. In order to analyze the data, a program called Statistical Packages for Social Sciences was used. The theoretical framework: there were 2 theories discussed in the study: the drought perception theory, which included 4 elements. These were drought experience, drought definition, drought expectations, and drought memory. And the second one was the sustainable livelihoods approach, which states that poor individuals have the important skills, knowledge, and abilities to create a sustainable livelihood approach to alleviate poverty. The recommendations for the study were women empowerment. It is important to involve women in the decision-making of drought and water security issues. Environmental education will help rural communities understand environmental issues. Sustainable agricultural practices is necessary to ensure individuals develop skills and knowledge to promote food security. And governmental interventions are needed, with more intense and frequent droughts occurring, since South Africa is a drought-prone country. Thank you.
From a very rural, municipality in Msinga, in central KwaZulu-Natal. Yeah. And then our next talk, now we are back physical, is memory. Read.
Okay. Thank you. My name is Memory Reid from the Global Change Institute. Good afternoon.
Today I will be presenting a paper that my colleagues and I put together. Essentially, we were trying to explore the relationships that exist between hydroclimatic variables and hydropower output in the Kariba Subbasin and the implications it has on energy security for Zimbabwe as a country that is heavily reliant on hydropower for electricity. So the study region for our study was in the Zambezi River Basin, and we zoomed in into the Zambezi Kariba Subbasin inside the Zambezi River Basin. Through there, we have the Zambezi River that flows, the Zambezi River flows through the basin. And as it flows through, you have the Kariba Dam that is across Zimbabwe and Zambia and forms the Lake Kariba here. It is the largest man-made lake by volume in the world. And the dam provides electricity for both Zimbabwe and Zambia. On the North Bank, Zambia gets about under 1,000 megawatts and Zimbabwe just over 1,000 megawatts on the South Bank. So we looked at data from the Meteorological Service Department of Zimbabwe. They provided meteorological data for precipitation and for temperature. Then we got data from the Zimbabwe National Water Authority that supplied hydrological data from the gauging stations that are along the tributaries into the Zambezi, and including one essential gauging station that determines flow into the reservoir of Kariba, that's the Victoria Falls Big Tree. So with that data, we then did long-term trends using Mencandle. So did a non-parametric test for climate, which is temperature and precipitation, and for river runoff. We did the same for the hydropower output at the Zambezi River Basin. We then also used graded maps using Copernicus to be able to explore the land cover, land use change in the area. And with that, we then did a correlation analysis using a Pearson correlation to see the relationship that exists between or amongst the hydroclimatic variables and the energy generated at Kariba. Our results depict that there is an increase in temperature in the Kariba subbasin, particularly maximum temperatures. And the trend was significant. But there was no essential increase or significant increase in precipitation, except for 1 or 2 in the wet season. Here also, we also identified a declining trend in the total hydropower generated in Kariba. As you can see, the trend is, oh shoot, I think okay, sorry. As you can see, the same slope for the green one is the hydropower generation, it's declining. But for the river runoff, the trend, the blue line, is not so significant. It's slightly increasing, but not significant. So what we then did at one of the sites where we have Victoria Falls Big Tree and the river runoff for that spot, together with the temperature and precipitation, we did a correlation analysis to establish the relationship between the variables. And there was a relationship, a significant relationship between temperature and precipitation, and also a relationship between the hydropower and the river runoff, thereby concluding that there is hydroclimatic variables have an implication on hydropower output. And then we also realized there wasn't necessarily much changes in the land cover, land use change in the area. And our result, and also what was interesting was the river runoff and the hydropower outputs mimicked extreme events in the river basin, like your droughts and your floods that occurred in the same particular years. And the results then suggest that we need to take into account climatic changes in the area when we're trying to grow or establish our hydropower projects or development in the sub-basin, as it is highly susceptible to climate change. I think my time is up. Thank you.
Talk is Roy.
Hi, I just wanted to, when I gave this talk, I wanted to give some context about some of the risk and vulnerability and adaptation work that's being done to give some insight into how the information that a lot of you are generating is being used. We're doing some work for Transnet, Transnet Port Authority, but it's been quite a long journey. In about 2010, Transnet started an integrated climate change strategy across all their units. In 2010, my company, WSP, undertook a preliminary risk and vulnerability assessment, looking at all the divisions. It was a high-level contextual document. And around about the same time, the CSR did a more detailed risk and vulnerability assessment for Transnet National Ports Authority. It was associated with the ports and all the sort of assets and operations under their jurisdiction. Then about between 2018 and 2023, there's been a number of small studies, big studies looking at extreme climate events, specific events. But the next major study came to conclusion at the end of last year, 2023, where risk and vulnerability framework for the general Transnet operations on a wider scale was developed by the CSR. And then at the moment, we also, from our side, the WSP is looking at developing a net zero strategy to 2040. It's funded by the French Development Bank, and that's for all Transnet divisions and operations. But the key thing that I want to talk to you about today is a collaborative effort led by the CSR. So it's got SAWS, it's got WITS, it's got WSP, and then obviously Transnet has funded it. And it's quite a nice integrated project, but it's quite constrained. It's constrained into the ports and immediate port operations space. But we do realize that it's going to have to be looked at in a wider, so looking at the associated transport networks and supply chains. So when you come to that sort of space, there's a very nice guidance document, PIANC Working Group 178, which gives a really good insight into specifically water-based port risk and vulnerability and adaptation exercises. And following that is also two guidance documents of once you've done a decent risk and vulnerability assessment, how do you make the decisions around adaptation? The way that the system works is basically you develop a context, the objectives, which is the picture. We can go drive it, eh? You drive it, Neil. Go down. Go down a bit. Yeah. Okay, that little circle. Okay, basically, it's looking at context objectives, getting climate information to inform the risk and vulnerability assessment, do the risk and vulnerability assessment, and then decide on adaptation measures. Okay, so if you want to go into a wide assessment of ports and all the associated networks, it gets complicated very quickly because there's lots of logistics involved, there's lots of other players. So that's not where we're working. But there are sort of examples of this. We have a team that have done this for the New South Wales ports in Australia. They've looked at that sort of wider logistics space. It's difficult because you have to do geospatial mapping. There's a whole lot of more levels of complication. But to sum it up, they found that the main risks for them were flooding, fires, and the most vulnerable aspects of their logistics chain were actually just the road networks, not the rail. Okay, so the risk and vulnerability approach, typically, you look at the vulnerable systems and operations, you look at existing risks. The ones in the past said there were waves and sediment transport regimes. Those were the major ones for the Transnet National Ports Authority. It was done by a specialist in waves and sediment transport, interestingly enough. Then the exacerbation was likely to come from changes in weather and currents, which was an exact place that most of the people at the project did not have a knowledge. So maybe that's just some risk assessment. Okay, so basically, whenever you do a design, we've done our assessment on an engineering design basis, so we can speak to engineers. You have a design basis, the frequency, the magnitude, the currents, the seasonality of the events. And when you do that, you use that and you design port infrastructure. You design operations. You design maintenance activities. And then the residual risk you manage. You manage in terms, our ports have something called APOS, which is a port operation safety system run by the CSR. So that's managing the residual risk. But we here are looking at trying to minimize the actual risk. Okay, so when we looked at it, one of the things we were concerned about was their slow burn effects, sort of sediment starvation of a beach, and then you have an extreme event, and then you see a major erosion. So that's your concern. But it comes from two aspects, the slow burn plus the immediate event. And then there's also the risk of conflating climate change and inappropriate maintenance programs. So often if you don't maintain things appropriately, you could have an event and you say climate change. It's not necessarily the case. So you have to be quite careful when you do it. So the project that we looked at, or we are looking at now over the next 2 years with the CSR and everybody, is that we're trying to look at informing the risk and vulnerability in more detail based on getting more information on the climate change and downscaling it. And the aspects involved, I just want to give you a quick overview. There's 8 work packages. It's the atmospheric forcing, choosing the scenarios, downscaling them. It's regional wave modeling. So it's actually looking at regional wave modeling of storm surge. That SAWS is dealing with that. CSR and WSP are looking at the local shortwave and long wave modeling. They're looking at tropic cyclone modeling for specific models, the changes in sediment transport. That's looking at things like shoreline change, maintenance, dredging, habitat change. We're looking at currents. That's effects of ship coming into ports. There's an ecological context that gives you guidance of the ecological assessments and adaptation measures required. And then the work package 8 of the thing is just a risk and vulnerability assessment. And we hope that we get somewhere that we can actually start making proper decisions on adaptation strategies. Yeah, that's it.
Okay. Iike. Yeah, you can pronounce me Ibi. Yeah, Iike. Good evening, everybody. Very happy to present my research work here. I am Dr. E. Kim from Yangon Technological University, Myanmar. Very happy to present my research work. Yeah, my research work is investigating sugarcane plant radon crop mapping from multi-sensor and multi-temporal under climate change. There are two types of results to present how much crop yield we can estimate. So in 2022, 2023, how much crop yield is produced by using vegetation index, both NDVI and MASAV2. NDVI is already know normalized different vegetation index. MASAV2 is modified soil adjusted vegetation index. So soil effect cannot reflect that when growing season, germination of the seed season. Because germination of seed plant is very small. So reflection from the soil disturbance. So that is why I use MASAV2 index. From this index, what we can conclude? Chlorophyll level. During the germination of seed, during the leaf development portion, during the plant phenology, when the sugarcane is ripened already, ready to harvest, then chlorophyll level start to decline. That is why I would like to show my result in terms of vegetation index. Another one is mapping how much area of sugarcane or radon has been harvested during harvesting days. Because harvesting sugarcane is not only in single day. In Myanmar, maybe this take 1 month, nearly 1 month, because sugarcane mills are not ready to produce sugarcane yields. That is why we need to wait. Then how much area I harvested? That is my second time. Let me present, depends on the methodological adopted for harvester fee. Firstly, PlanetScope 3 meter accuracy satellite image has been downloaded and data pre-processing had been used. That means data processing means and crop area interested, 38 acre sugarcane field. After the cropping, then I use and these image area interests are temporary satellite image, data from 36, total 36 image for plant phenology, sugarcane plant phenology started from April to February. So total 36 image has been used. And pre-processing, after pre-processing, which place is sugarcane, which place is rattan? Because rattan is harvested earlier than sugarcane. So I use GPS software for collection of ground truth data. So latitude and longitude of this place is sugarcane, this place is rattan, this place is another manigram or not interested class, manigram, green gram, sesame, I don't interested, but nearby grass field. So geolocation is collected. After that, indices generation, this Masavitu indices has been generated because my satellite data are year-long data, 36 data from 2023 April to 2024 February. So a lot of data to reduce multispectral data dimension. I need to use indices generation. That is indices generation for single date image. For temporary indices generation for 36 date image, I use temporary indices generation. Then loss of data, then data and decision. Which information is more effective to decide optimal dates? Then optimal date had been done by using probability analysis, which is based on Euclidean distance. I calculate Euclidean distance between target class sugarcane, non-target class, nearby grass or something, green gram, manigram, I don't interested, non-target class. So superiority analysis, after that I classify using these ground truth data, training data, I use fuzzy machine learning based possibilistic semi classifier, PCM classifier. This is sub-visit accuracy. Accuracy can be done by using sub-visit accuracy, not only single visit, sub-visit accuracy. Then how to assessment my classifying results? I use mean membership difference. They give heterogeneity within the class, MMD. This is the assessment technology. After that, single day image and another harvesting days plus my classifying image are mapping together to get which day has how much acre harvested, which day have how much acre harvested. In this way, I know how much acre or sugarcane has been harvested. So I can use crop yield production from crop mapping and this vegetation index. This is my present research for future step. Empowering climate smart technology, CST, using not only satellite-based remote sensing technology, but also Internet of Things, IoT-based, so that smallholder farmer can estimate how much water requirement, what is the weather condition, what is the swine fertility, and etc. Everything they can monitor. That is my future scope, and I intend to use starting from smallholder farmer because for broader area, this is not within my limit. Thank you so much.
Thank you. I can. And then the next talk will be by Michaela Taglon.
My name is Michaela Daglon. I work at the University of Cape Town, and I'm here to introduce HABVIA, Heat Adaptation Benefits for Vulnerable Groups in Africa, on behalf of the project's many collaborators. HABVIA is a prospective longitudinal cohort study of 240 participants investigating heat-related health outcomes in vulnerable populations in Ghana and South Africa. In each country, one site is urban with high building density, and the other is rural with lower building density and more green spaces. The study sites you can see on the map, Kailicha in Cape Town, Impego Village in Toyondu, Gamashi in Accra, and in Kwantakesi, which is just outside of Kumasi. The primary objective of the study is to assess the efficacy of passive cooling interventions on several key physiological health outcomes, including sleep behavior, hydration status, and core body temperature, as well as on mental health outcomes and building internal thermal conditions. Health data is being collected through a combination of contiguous physiological measures, questionnaires, and periodic biochemical measures. Environmental data on the outdoor climatic conditions is being provided by the Ghanaian and South African meteorological agencies, and we are installing fixed iButton sensors to record indoor temperature and humidity in the participants' homes. We have also surveyed the housing residents and dwelling characteristics, and we hope to develop a localized community-based early heat warning system. So it is a very ambitious project. We started our baseline data collection in November of last year, and we've just wrapped up in April. During the next few months, we will be workshopping with participants to make sure that the interventions we hope to implement are feasible and have community buy-in. We will then repeat the measurement periods during the hot season for an additional 2 post-intervention years. The preliminary data that I'm going to present, can I do that here? Okay, great. So this preliminary data is just cross-sectional associations between nighttime indoor temperature and various sleep parameters. Sleep data has to be scored by hand, so I only included 11 participants, equating to 70 observation nights collected between the end of November and the beginning of March. None of these correlations were statistically significant, owing probably to the small sample size. But what we can see is that there is a lot of variability in sleep duration. So along each of these graphs on the x-axis, we can see the average nighttime temperature, the indoor temperature collected between 8 p.m. and 6 a.m. And then on the y-axis is various sleep parameters. So duration, lots of variability on the left there. In the middle, we see sleep efficiency, and we can see that people in Khayelitsha are generally sleeping poorly, given that we would expect a sleep efficiency of at least 85% in a normal healthy population without any sleep disorders. But interestingly, what we do start to see is a positive trend between increasing nighttime temperature and percentage wake time, which suggests to us that high ambient temperatures during the nocturnal rest period are causing a greater disruption to sleep, and this will have many adverse health outcomes in the future. So just as a caveat, none of these associations have accounted for health comorbidities, which we know impact both on sleep as well as our sensitivity to temperature, including age, body composition, or non-communicable disease status. So these things are all going to be looked at. As I mentioned, this project is in its very early days, and we hope to present more comprehensive results in the near future. Thank you.
Okay, I think our final talk for today is by Nicola J. van Wilgen.
Thanks for bearing with me for the final talk of the day. Ours is somewhat unique in that we've chosen to go for no maps and no graphs because I didn't dare show you my data because, as Bruce discovered during lunchtime, actually we just got some data from a friend who we knew who had access to data, and it's actually really the wrong stuff. No, so I work for South African National Parks, and we have a really unique challenge because conservation management has traditionally allowed for management within flux of range of historical conditions, and the transformations that we're seeing at the moment in some of our protected areas have never been observed before, and there's no manual for how to deal with this. So the types of impacts that we experience in our national parks are broad. I've just put a few pictures up there. So we've got anything from impacts on species like die-offs that have been mentioned of birds under extreme heat conditions, to impacts on access through roads and facilities, to impact on people's ability to work outdoors, tourist experience we've heard a little bit about today. And some of the impacts can be immediate, like the birds dying, and some of them are slow and subtle. So there's a picture from the Richtersveld on the left where we're just losing massive populations of species. And nobody's really knowing what to do about this. And you can speak to my colleague Wendy for more information on what we are trying to do. But I think the real challenge is at the moment, Sandparks and many other protected area organizations are self-funded, or in our case, around 80% self-funded through tourism, which puts a massive constraint on our ability to practice adaptation. So we initiated a number of types of response actions, and some of these are really small, trying to develop early warning systems for key assets. Like there we've got our penguin breeding sites, and we're trying to look at storm surges and heat waves and things that can affect penguin breeding success and providing alternate habitats. But then we also require much broader adaptation strategies. So, for example, we're doing scenario planning with managers to look at how robust our different management strategies are under different plausible climate futures. We're looking at different models of protected areas. So, for example, under the whole 30 by 30 initiative, trying to expand our protected areas, how do we do that in a way that is meaningful for society, not just for biodiversity, and really integrate land use more meaningfully? But we've had a number of challenges. So the first is that, one can recover from one extreme event and do something about it, but your ability to keep doing that over time is eroded. And we heard earlier about maladaptation, and at what point are your short-term interventions actually restricting your longer-term kind of ideals that you'd want to be on? And it's really difficult to get buy-in, firstly, because many of our short-term impacts are really difficult and they require a lot of intensive thinking, and there's just not time to think about the slightly longer term impacts. It's also challenging to make people do something when you tell them, well, it could be like this or it really could be like that, and we have no idea of telling you which way is the way. And then it's also been really difficult to stimulate thinking, what is a completely different way of doing things look like? And the reality is that we have some tough decisions to make. Are we going to drop fences? Are we going to put up fences to keep out disease, or, keep out whatever else? Are we going to cull animals? Are we just going to leave them? Are we going to feed them? Are we going to give up on conservation in protected areas and go ex situ and have seed banks and gene banks? And, the reality is that there's some poor guy sitting in that national park making these decisions with very little information, very little money, very little, it's like no money, no friends, and no time. And, what advice do we have for these people? So while the world is wrapping its head around, what are the ethical and practical solutions to this, with really a focus on what's happening to people, what is happening to our world at large is kind of left up to that guy, which is a little bit scary. And I think the one solution is potentially to look at alternate funding models for protected areas that will alleviate some of these trade-offs that we have to make, because the consequences for future option value are enormous. And there's a time lag in our experience of the effect of that. And so we really need to be doing something about this now, even though the information we have at hand is not ideal. So we're very eager to engage with you and to learn more about the products that you have and ideas for how you think we can use them. Thanks.
Yes, thank you very much. Yeah, that was exactly 5 minutes. Yes, thank you. I think, in the interest of time, we will only have a chance for 2 comments or questions from the House, if there is none, and maybe short questions.
Thank you, Facilitator. I don't raise questions. There was a presentation for Lake Kariba. Yeah, I think there's one issue that we've picked in one of the papers we published, I think, towards the end of last year. It's not only climate change. Basically, it's absolute political maneuver of abstracting beyond what they are allocated. So you need to be careful about that one, because you might just say climate change leading to reduced water levels and degeneration in north and south basins, but actually there's a lot of violation of the quantities that the countries are supposed to be abstracting. Thank you.
Thank you. That's very nice. Is there any other question or comment?
Sorry, thanks. Also on Kariba, very interesting point there. I must say, but I was wondering in your model how you incorporate land use change and land cover change that seem to be very physically driven, but biology matters when it comes to water. Do you want to comment on that? Thanks.
As you saw, I co-authored the paper. I didn't do the land cover use change analysis, but from my understanding, he used a tool called Copers and used 300-meter resolution for that area and extracted the maps that had the images for that area as they came across for the period that he identified. So that's the best I can give you.
Thank you. And maybe there, if you do your classification, maybe if you can do a time series of that, you can do classes and, you know, calculate total classes, total area of those classes and have a time series so that you see changes less. We wanted 2, but we can add 1.
3 is better than 2. Just a comment about the nature conservation and the biodiversity study. I mean, what this is showing us in many remote areas, which aren't subject to very often other human pressures, the local extinction of species that have existed for a few million years. So this is a sign that climate is moving out of a range which we've seen for a few million years on the planet. And I think that's an incredibly valuable set of data for us to be able to really gauge the impact of climate change on biological systems such as ours. So I think these sorts of studies go beyond the pure conservation, and of course conservation is important, but it's what it tells us about our environment and beyond the simple metrics of temperature and rainfall, what it means for the actual existence of life on our planet. And I'd really like to point that out as an extreme event unfolding before our very eyes, because we've warmed our planet out of an ice age. We just haven't realized it yet.
Thank you.
Move us along. Kuto, where are you? I was going to ask you whether wet coal is a real thing, which I assume it is, right? We're just going to use adaptive management under extreme circumstances. Get it? And I was going to make another joke, which was that it's, what was it? It was lethargy, it was lack of concentration, poor sleep. I think we must all be suffering from heat stroke, right? No, look, so we want to use this opportunity that we all gather together. It's a rare opportunity these days to have a really good group like this together. So we're going to sweat this asset as best we can, but within reason. So now what we're proposing is we take a tea, which I just hope is ready, coffee, because they seem to be organizing here. And then I propose we come back at 4 o'clock. Okay, don't go away. And at 4 o'clock, what we'll do is we'll have a half an hour or 3/4 of an hour group session, got some really interesting and challenging questions for you to address. And then we'll have a plenary report back, and then we can go and drink the wine and eat the food. Okay, so the reward for sitting through the last session post-lunch is to go and have some more coffee and more food. Okay, and then I'll call you back at 4 o'clock. All right. That's a deal, right? No one's allowed to go anywhere. Thanks. Jonette. Okay. All right, listen, so folks, tough as it is, we are pushing on through. And your reward is delicious food and wine and coffee and cool drinks after the session. So again, I want to stress that what we will have to produce and to show for this conference is not just the presentations that are offered, and they're very important and valuable work. But more importantly for us is to draw on your collective thinking, your collective experience and knowledge, and to try and collate that into a good document that we can present. And already we've engaged with several of the stakeholders who are very keen to see a document come out of this meeting. So these discussion sessions are not just for fun, although hopefully they are fun, but they really are to use this very rare opportunity to think and to talk, and to record this this thinking. So what we did again was just to adapt the kind of stimulation of the conversation by listening to what people were saying and considering what has already gone down. And so I'm going to move to this microphone. Yeah, so you know, again, as I stress, we try to disaggregate the whole concept into themes, and the conversation has kind of followed them, but not entirely. That's okay too. And so for this kind of looking at risk and vulnerability, this morning when we broke up, we spoke about data information and communication of that. Here we're talking about risk and vulnerability assessments and understanding that. So we thought we would ask you to go into your groups again and spend half an hour to 3/4 of an hour considering this concept or this idea, and then come back to us with some ideas that again we can ask you to send to us. So just to read the questions as they stand now. How do we determine the required specifications, for example, time and space scales, for early warning systems for ECEs, or even responding to early warning systems, to ECEs, at the appropriate scales, those time and space scales, for different sectors? Wait, this is not the most, is this the most up-to-date one? I don't think so, no. This isn't the most up to the one that's most up to date. I'm sorry. Just bear with us while we do a little program change. Is on my computer. I didn't update it. This is an older version. We thought about, don't read this. So I'm just going to get him to swap them over. This is all embarrassingly wrong. Is this the new one? Yes. Okay, good. Okay, so no, it's one before this one. Sorry, slide number 3. In fact, so what happened is the one that's on you. Oh, is this the right one? Is this the right one, Guy? Okay. Yes, this is the better one. I think this is better. So how do we determine the required specifications at relevant time and space scales for ECEs, EWSs, for different stakeholders? For example, municipal infrastructure might have a particular demand for a particular kind of specification versus fire management, wildfire management, or other kinds. They might have different requirements, or health impacts, for example, or drought. All of these may have different requirements in terms of the specifications that they meet. We said time and space scales, maybe there are other considerations. I don't know if I've said this already in this group, but one example is when we did a post-mortem for the July floods, July 2022 floods in Durban. The Housing Development Agency people said we needed to know, where can we move people to now, not in an hour's time or in 6 hours time or tomorrow, but now, from where they are to where they can be safe. Where is it going to be raining? Where is it going to be flooding? That might be very operational, as opposed to municipal infrastructures who have different time and space scales. So the question we'd like to consider is, how do we determine those specifications? What process should we undergo? And then a second question about vulnerability and risk of vulnerability is not so much the who, as in the entities or the applications, but the who in terms of elements of our societies. So how do we better produce risk and vulnerability assessments that are cognizant of the spatial distribution of socioeconomic realities? For example, formal settlements versus informal settlements. So there again, the early warning system specifications and applications might be very different to different segments of our community. And so, so that's something which we want to also consider in your conversations of risk and vulnerability. So again, these are guideline questions. You can interpret them if you want to, and add your own points which are not evoked by those questions. So I'm going to ask that we go to our various color groups. For those that are only arriving now, your name badge has got a color on it, and there's a color. Well, I think the blue group was there, but the blue sticker's gone. Somebody keeps taking it down. I think it's because they're moving the door. So the blue sticker is there, red, black, green, and yellow, orange, and another color, purple. Is that? Oh, okay. If it's too cold or they're busy setting up for the event, then come back inside. Okay. All right. So I'm going to let you go to your groups. We'll give it half an hour to 3/4 of an hour and see how the conversations will take a sort of measurement of the mood, and then we'll call you back, and Nicola is going to chair the plenary session. Okay, thanks. So off you go. That's our deal. Let's see if you can manage.
Thank you. So you've given me a terrible task because you gave me the last talk of the day, the last chair of the day, and a question that nobody understood. So I want to see which group thinks that they understood this the best, because you're going to go first. Otherwise, I'll pick on my own people who thought we had it all sorted. Okay.
I don't think we understand it best, but I have something to say. Okay. So we thought for the first question, the first thing to do would be stakeholder engagement, but not really the traditional one, more where we explore their decision scales, where we understand they get to describe their pattern of operations, asking what triggers their decisions, exploring with a decision maker what to them constitutes an extreme event, and what disrupts or breaks their normal operational procedures, because they will have different thresholds and triggers. And also a mapping exercise of who are the stakeholders, because there may be obvious ones, but also ones that are not so obvious. And then identifying critical thresholds and metrics. And then for the second question, there was a bit of an issue with the we, where we thought that we should not necessarily be the one doing the risk and vulnerability assessments, or the ones to lead it, but to bring in the risk and vulnerability assessors. So we feel that we should be included, but not the ones to lead it, but that we could be the ones creating the spaces for conversation, collectively bringing in a pool of expertise and using tools such as structured listening to create common understanding. Yes, thanks.
Thanks to the yellow group. So we had a lot of discussion around the processes that are in place, and it seems that there might be a lack of awareness between different groups of how things are actually working behind the scenes. So I don't know if I can be really cruel and call on my own group to report back on some of our discussions, because I think that might be enlightening and lead to some follow-up discussion.
Thank you.
Okay, yeah. So our group, I mean, we spoke also at first about what is, risk and vulnerability, and, what goes into the pot to determine that. And then, yeah, we spoke about what type of emergencies that we are looking at, that will determine the time and the scale, because different ones, some will be more long-term, some will be short, and also some more local, and some will have a bigger impact. And in terms of the sectors, the people from Cape Town and some were talking about, there are systems in place, but it's more provincial, and I don't have all the detail, but in terms of, oh no, actually that's the second question I think that I'm responding to now. So there's a need for a response plan. So for different sectors, for them and methods for them to disseminate the information. And there needs to be an order of how it should be done. And it will be different for different role players in terms of what you disseminate, to whom you disseminate and how you do it and so on. And yeah, so it does, I mean, it is actually linking to the second part. So, and I think what they were saying that you need to involve the community because there are different, for the same type of risk, people will respond differently. I mean, whether it's in Khayelitsha or whether it's in Constantia or whatever. So the coping ability and so on will be different. So you will have to put different things, have different things in place to actually respond to that. And then in terms of the second question, yeah, please shout if I missed something from what we said here. But in terms of, the better assessments, we also said that you need to involve stakeholders and to educate the community of what their potential disaster events are. And that should actually be a continuous thing. People should get to know, what are the hotspot areas and in terms of basic things like cleaning your gutters before the rainy season started and not putting stuff in your water, what do you call it? Where the water goes in the rainwater systems and so on. To understand for people and to understand what are the vulnerabilities and so that they can be more resilient and more prepared when these things happen.
Yeah, so I think that was a good summary. We spoke a lot about what is the difference between risk and vulnerability. So different people in different parts of a city or a town might have different vulnerabilities in terms of their ability to respond to particular disasters, and you would need to implement different parts of your plan. And it sounded like disaster risk management has some really good plans, but what we discussed might be lacking is that you might not need to disseminate all the warning information to everybody, but people should know that when they receive a particular type of warning, what is expected of them in that moment. So it's kind of far in advance planning that your community is aware of the types of warnings they might receive and what they should do in those circumstances. And then, as she mentioned, also what one can do in preparation to minimize your own exposure and vulnerability to those particular events. Like she's mentioned some examples of gutter cleaning or so on. Neville.
Thanks. Yeah, I mean, we didn't think too deeply about the words we were using here, but now that you mention it, I actually learned from the NDMC about, how to unpack risk, and risk is comprised of likelihood and likely impact, because that varies. And then it also has a component of resilience in it and various other things. So I do appreciate the fact that these are hell of a complex. And it also struck me to say, just to reemphasize a point that I think was made in the first comment, and I want to give the example, Roy and Vuyo at this conference gave input on ports. And we started, I'll speak for myself, I started working with the ports, a couple of years ago more directly, and learning about port operations at the detail that they are experiencing is critical for anyone who wants to engage with a stakeholder. I know I'm stating the obvious and preaching to the choir, but nevertheless, the example is good. And for example, in the port, one of the biggest challenges, imagine there's a big port, these huge, big container vessels coming in and passenger vessels coming out. What's one of their biggest constraints is getting the pilot onto the boat, onto the vessel that's coming to the port. That's one of their biggest problems in heavy weather. We couldn't have known that without having a conversation with them. And similarly, as I think I might have mentioned earlier in the meeting, that if we look at the statistical distribution of extreme wind and wind gusts, as you might all know, the Port of Cape Town suffers a very serious wind disruption problem. And if you look at the statistical distribution, and you have a standard deviation or second standard deviation, say, okay, anything above that is an extreme. That's way above their threshold. They get disrupted at a level which is not extreme, but is extreme for the crane that carries the very heavy container across the berth onto the ship. And so to know the detail of the stakeholder that you're concerned with is vital to understand their problem. But it works the other way around too. And the other way is that many of the stakeholders don't know what when I say we, climate science potentially, or let's say weather forecasters, etc., can produce. And it really is an iterative process. But the question really is, how exhaustive can you be? Do you go to every single stakeholder, every single community? How do you get that level of preparedness? I mean, and so that's really the challenge, is how do you sort of cut up or divide or get a division of labor which is workable to the extent that you have enough information to produce the right kind of, and generally it's always reactive. After the event, we should have known this. Next time we'll be prepared. Thanks.
Thanks. Yeah, we also had those discussions in our group around different people responding differently. And I think when it comes to extremes, we mentioned, you know, Cape Town's very good at dealing with wind extremes and rain extremes because we have them a lot. And so we've developed plans. But what are the novel extremes that we've never experienced, like the heat waves in Europe that were mentioned yesterday? And if you're not used to that kind of thing, it might just be that you don't know how to behave in that situation and therefore you're overexposed. So yeah, I think new extremes is also something to look out for. Yeah.
Just touching on what Neville was saying with how detailed do you go? It was actually disappointing because we started touching on this topic with regards to communities with people living with disabilities in them. So we just assume, oh, sending out a WhatsApp or hearing something over the radio is a viable means of communicating a warning. Well, what happens if they have disabilities and don't have, or can't hear, can't see, can't easily move out the area? How do we deal with that? And that's, I wish that discussion actually got more detail into that, but it was just interesting, like that detail, we overlook that. We say, oh, we can generalize. But no, it's not the same for everyone. So it is a valid question, how much detail is required.
All right, thanks. From the group that I was part of, we first acknowledge that when we talk of early warning system and the stakeholders, we are actually talking about a spectrum of cases. And we thought an approach that can help to optimize the value chain of early warning system is that which could take all the stakeholders involved in the co-design, co-development of the early warning system, such that you involve, for example, research partners, the end users, as well as the service providers of such early warning information systems. And in that process, if, for example, you take a sectoral approach, you could actually put together collaborations that thresh out the needs of a specific sector. In that way, we'll be able to talk to the issues of the relevant time scale and spatial scale because they're actually informed from the user perspective. The other aspect that we discussed was on the aspects of risk and vulnerability. What we acknowledge here in this case is that often the assessments of risk and vulnerability, they are limited by the components of the definitions that you are using. For example, you often have a situation where if you want to do assessments at specific decision relevant spatial and temporal scales, you are limited by the disaggregation of the information that you receive, which is often aggregated at district level in some cases, or even at a provincial level. So these are some of the things that perhaps we could go into the data that is requisite for risk and vulnerability and streamline the aggregation of the data such that it can permit higher resolution details of understanding of climate change induced risk and vulnerability. Again, here, this is something that can be done according to the relevant sectors. Thanks.
I just want to go back to your comment and endorse it that we need more research on unprecedented extremes. I know at least one proposal that's in on that topic, but under climate change, we're going to get more of them and we need to have a better understanding of this.
Thanks. Yeah, and I really like this idea of at what scale do you do things at. We had a discussion in our group around being prepared long in advance and knowing what is expected of you, but then we also discussed what happens during the event and their novel ways of contacting people. And I think having different methods of contacting different people, we spoke about messages directly to your SIM card. We spoke about radio broadcasts like we experienced in the US, interrupt this broadcast, get out of the way, there's heavy thunder and hail on its way.
Maybe a slightly different perspective, but I'm not hearing discussion about nonlinear effects and threshold effects, which may really help to focus these risk assessments or vulnerability assessments. So an example of a nonlinear effect is the force of the wind on structures rises with the square of the wind speed. So it's nonlinear. And we saw that in Stellenbosch a few weeks ago, where the wind exceeded a certain gust strength and a whole bunch of walls and fences started falling over. And that's that effect of the nonlinearity. It just overcomes a whole lot of limits. And then the tipping points or the critical levels, something like 34 degrees and 100% humidity can cause human beings to die because we can't sweat anymore at those levels. So if those sorts of critical limits were well described for a whole range of sectors, it would really make the risk much more. And it may differ for different socioeconomic circumstances. So those limits might be different. And that would be really important to understand.
That's a really, really good point, because I've never been scared of wind before, but at 7:35 a few weeks ago on that Sunday, everything fell down in our entire neighborhood, and we actually finally got the insurance quote yesterday. But if the weather station broke, so it recorded 303 kilometers an hour, but it also recorded 800 mils of rain, so clearly it wasn't working anymore. But if someone can tell me what the wind speed was, I will tell you at what speed roofs disappear and walls blow over, because I know exactly when it happened. Yes, it certainly did. All right, any other groups?
I think not just to add a particular part of the discussion we had, that was around, even if you do get the message out in time, there's a high level of variability in especially rural communities' ability to respond to it. So there's a question of whether they hear the message, social media, radio, whatever the case may be, but then can they respond and how do they respond? We know where the emergency assembly point is outside of this building, but where is that for the community in Ngeni that we heard about earlier on, right? So that's the one question. The other question is that we had a number of interesting case studies and examples from communities which had community structures not put together for the explicit purpose of disaster response, but which were there for other reasons. So for instance, the one example we had was a catchment management agency-based water quality initiative that had a strong community group responsible for water quality and reported pollution and such, and this turn could then be a sort of a grouping in the community that can respond to other warnings as well. But we can't plan to have a health group and a water group and a flood group all together in the same community. There's got to be some central point, and I think the lack of such structures within a community is probably a significant hurdle to effective response, even if the communication is timely, perfect, from a proper early warning system. Thank you.
Yeah, okay. I think that speaks to identification of the local kind of dissemination pathways that disaster risk management needs to reach.
Thank you, facilitator. I think one of the issues that was coming in our group and also as we're discussing is the idea of harnessing local knowledge. So you discover they're already dealing with their own early warning systems that are much more effective than government early warning systems. So we need actually to capture that. One of the examples is the HANOPS. For those that are from Gauteng, you know, the floods we experienced in the HANOPS catchment. And these people have literally built on top of the river. Now, this is not fiction. So they are bringing all these construction vehicles for 100 rand. You dump, you close the river, you keep on going. If last year's flood was this high, you keep on going, and they are there. Structures have actually sprung up. So they also have got very sophisticated early warning systems within them. And then the other issue that should be investigated seriously is the traditional versus modern governance structures. If you are in the Ingwenyama Trust, early warning system should come through the Ingwenyama Trust. If you're in Cape Town where there's no chief in Cape Town, there's no kingdom here, it's fine. But when you go to KZN, Eastern Cape, there are lots of traditional leadership institutions that actually are in conflict with the government. So there's a lot of things that actually can be suspicious when they are coming from the government as opposed to traditional leadership. So this is actually the complexity that we need to deal with as we move forward. Thank you.
Absolutely. And we do have First Nations groups in Cape Town as well that actually don't even believe in Western government structures at all. So reaching those groups is a major challenge.
Thanks. I just want to pick up on a few threads. First of all, the unprecedented use of the word unprecedented is reaching some new record extremes. No, but it is interesting to consider that and what it really means. I mean, I actually haven't got much further thought on that other than to say the difference between, let's say new records as opposed to areas experiencing unprecedented change is a gray area which needs to be explored. That's interesting. But I want to just get back to what Maha was saying about working through the sectors and where's Dawn? There. So Dawn will bear me out here. The National Framework for Climate Services process has identified 8 sectors. I think much of that comes from the global level to our level. There are 8 priority sectors. And the design, again, which I think is so intuitive, is to have a user interface platform. And the idea of that is to create this engagement in those sectors. My concern is about the granularity, because when we get into a sector, let's say we're going into transport or housing or health, there's subsectors, there's different kinds of sensitivities to different elements of those sectors. And so I guess one has to sort of decide at what level of granularity you want to get to. But I'm reminded of, I'm not sure if it was COVID. I remember in the HIV era, not that it's over, but what I mean is when HIV became something very important in our society, every government department, every unit at the lowest level of granularity had to respond to some plan around HIV action, that each individual person was reached, within the system. And in the same way, I suppose one could devolve that process down into the sectors and then bring it back up for some more aggregated thinking. But the danger is you miss something. And so there has to be a way to kind of decide what is the granularity of consultation without it being too exhaustive. And I just wanted to respond to one other thing that Byron said, which was inability to respond indeed is part of this risk and resilience element. So I remember that like resilience, again, this is Declan, who was explaining to me things like how close is a hospital, how close is a fire station to where you are, kind of impacts your risk because of your ability to respond to that particular hazard. So those are just some picks. Thanks.
Yeah, that reminds me of when you get on an aeroplane, they always ask you to check where's your nearest emergency exit. And we kind of know how to do that really easily, but we don't know how to do that when it comes to these extreme events. So maybe, some daily practicalities that we can implement is the way to go. I've got one more comment there. I don't know what time the session ends, but okay, all right. So you're going to have to really brainstorm. I've got at least 4 hands. 1, 2, 3. So maybe we can go 1, 2, 3, 4. Okay.
Yes, I think one aspect that is easy to maybe neglect in a setting like this is who is, if we talk to human beings, which people are actually vulnerable. And in one project, we made an observation that the vulnerable are the people sometimes in very remote location with no access to internet, no radio, and sometimes with no ability to read and write. And when you think of an early warning system that could actually safeguard the life of such person, we need to probably think innovatively beyond technological means, perhaps aspects of traditional flows of information would become critical, as well as the abstraction of the information such that it allows uptake even for people who do not have the knowledge and ability to read and write things.
I just have a question for Neville, actually, to respond to. A lot of the questions you've given us in the breakout groups have used the word we. Who is we?
Do you respond to that before Wendy? Can I let Neville respond?
It's all of us in our whole society. No, I don't think that. Well, I don't know if I made any assumptions about the we. I mean, I could have written I, but I think that would have been pushing it, right? I don't have an answer.
I think you should have written I, and then we could have given you a job description.
Thanks, Nicola. So our group had many of the same, obviously jump in and to do consultation, but a couple of things that I think are key. One of them is when we're identifying stakeholders. Obviously, it's going to be impossible for us to plan to get down to every kind of user right to the ground and, every shack. But I think as part of that process, we need to be mapping out who all the stakeholders are and setting up a network. So you're getting the right people and ensuring that goes down. And that's what we can do. We can't literally man the WhatsApp groups. So it's, I think, a key part of the consultation. Then we spoke about participatory action research. I think one of the things to be cognizant of as we sort of try and set it up is getting an evidence base going in terms of obviously what actions are getting done. What are we doing? Do the messages actually get out there in time? And then what are the outcomes? Does it help? And I think those are really important for learning and to set it up right up front in this early stage. Then also, I think we said then really needs to be a considered effort to help other users to understand what it is they're getting and the uncertainty. So to not put their lives entirely in our hands and to be realistic about what we can give them. And then lastly, there's the disaster risk response actions that we take that are very short term. But again, cognizant of how we're driving the longer term adaptation agenda. So not to deal with them independently and to really work at the trajectory between them.
Thanks. You just reminded me of another discussion in our group around misinformation, and it came back to having a central voice for a particular type of warning. So don't listen to the fire warning from the water department, listen to the fire warning from the fire department. Don't generate and circulate AI images of your neighbor's house blowing away because it's not helpful. And I don't know how one potentially polices that kind of misinformation, but I think having a known single source for particular types of information can help reduce the potentially negative impact of misinformation on these groups. Sorry, there was a hand. Oh.
Thank you very much. I think one point that has been touched on was the incorporation of local survival knowledge in the early warning system. Very, very important also. One example that was made in our group was an example in Kenya where somebody from a disaster practitioner was asking a lady why she's not leaving her shack. And she was saying, if I leave, somebody will come and loot my stuff. So you see now that also speaks to response, to say as we develop these instruments, we need to be cognizant of people's circumstances. The other issue, I think, from a policy point of view that can help as we look at robust R&V assessments, if I may use robust loosely, is the whole issue of your indigence policy. If that policy is done correctly, you know who are your indigent groups in that local municipality, who's not able to bounce back after a disaster. One group member said you can even look at the number of cars that are there per household. That may also speak to issues of evacuation during a disaster. So you look at the ground, you look at the assessment of those vulnerabilities based on some of those instruments. For transport departments, it's also crucial for them to have accurate information of which roads are accessible in times of disasters, so that they communicate that information appropriately. Because you may drive to a place, find that there's a low-level bridge and you can't cross, then you are stuck. So that information needs to be accurate and it needs to be disseminated on time. Agriculture community, who's in short, who is not in short? Subsistence farmer versus a commercial farmer. Informal settlement versus a formal settlement. The ability to bounce back differs a lot in terms of those variables. The level of education, again, the level of awareness also becomes critical as we do risk and vulnerability assessment. Some people may be aware, of course, but be reluctant to respond. Others may not be aware at all. They may see a weather forecaster on TV, but not know exactly what it means. So that actually also comes into the fore in terms of response. The building material that people are using in terms of their homesteads and their settlements, all of those issues become important. I think the key thread here is a careful analysis of the stakeholder, the type and the nature of hazard, the magnitude of the hazard, as well as the conditions on the ground. Who will use the information? Human settlements may need to build the homesteads later, but a disaster practitioner needs the information now. Where is the thing taking and who needs to be evacuated? So the timeliness of information becomes critical also depending on who the responder is, primary, secondary, or tertiary responder. Thank you.
Yeah, those are excellent points. And I think I'm starting to understand parts of this question now. So the time component really links very clearly to the vulnerability. We spoke about if you're in Cape Point, there's only one route to get out. So you need to know a lot earlier that you need to evacuate than, say, for example, if you're in a place where there's 5 or 10 exit routes. So I think you made some really important points there on practically how these warnings need to play out in time and space. Right. Do I see more hands? Great, because I've been told we need to keep going. So I've got 1, 2, 3.
Thank you. Okay, from the pink group, most of our points have been covered, so I'll just highlight the ones which haven't. So one of the key things we just thought is we need to, we need to educate our stakeholders on having realistic expectations from early warning data. And also to help with this, we would draft like a template for data request to guide the expectations so that it informs the timescales as well in terms of the data that is requested. So and also it's not just educating our stakeholders, but it's also educating the communities as well and educating people in terms of these early warning systems, how they are interpreted and the severity and the impacts related. So we're also looking at ways of improving the early warning systems when communicated, the feedback maybe request feedback from communities, request feedback from especially stakeholders who would make a formal request in the template that we would have developed. So then request feedback, how was the data useful? Were you able to interpret? Were you able to understand it? And also, if there is need for more intervention in terms of further education, we sit down and have that conversation in terms of the application and also the impacts based on the data that has been supplied. And then we also look at holding the stakeholders or whoever requests the data accountable for that data, because at the end of the day, they've got information to prevent from lives being lost, livelihoods from being changed, and all of that. So to put it, and it's a whole decision-making process that just needs to be re-looked at. And also making sure that people take accountability, and especially when we are looking at the various spheres of government with the power they have as well. And also in terms of communication, we looked at also looking at the actions that are taken from the data that has been communicated. So what were the action plans, and also those actions that would derive from there, can they be measured, and how can we improve them, and especially at municipality levels as well, because different municipalities will do different things. Some municipalities, okay, we'll file it, we're done. Then other municipalities will take it and say, okay, we're going to draft steps, we're going to be strategic, and we're going to make plans, and we're going to do something about this data that we received. So yeah, essentially we just want to look at engaging and communicating with our stakeholders and communities to inform the data that we have, and also to inform the quality that comes out of that data, and the fact that people actually understand what are these early warning systems and how they are impacted in their lives, not just on a high level like it's only government that will be impacted. It's all of our lives that will be impacted. Thank you.
Thank you. Good afternoon. Thank you again. Strange enough, we are from the same group, so I'm just going to expand on some of the key discussion points that we have had. When we had explored the first question, the issue around the required specifications were aligned to timescales. So we unpacked the timescales as in categorizing it before, during, and after. So having to look at what may be required well before these extreme, climatic events, and then perhaps how that may change during and then post as well. What was also critical was having to understand, so at which point do you require, what do you require, why would you require it, and more importantly, how? And the how looked at, is it going to be used in terms of specific actions, or more importantly, what type of decisions were going to be based on what would be received during whichever timeline one was looking at that. What was also very critical for us was the fact that the M&E mechanism that we spoke about should actually allow us in terms of ensuring a great degree of relevancy of the data that may be required. Equally important was the fact that allow for flexibility in terms of the information structure, the type of structure that we present. It was very clear that there will be variability in terms of the sectors and their requirements, as well as the capacity that they would have in terms of applying what may be made available. The important, example that we have taken is that we may provide uniformed information, but how they would be used in a certain province or a certain municipality may vary drastically based on the resource and the capacity that they have. So these are the, silent issues that may warrant further, interrogation. Thank you.
Thanks. Yeah, I think that after component is really important, and some of the other groups also touched on it, like what went well and what didn't go well, and what would we certainly not want to repeat. We heard stories this morning of warnings that had been made after floods decades ago, and people have gone ahead and built highways in those places, and that was just not wise, but somehow we do these things. So I haven't seen new hands, but you have a very unique opportunity right now. If you feel that 5 minutes was not enough for your poster, I think I can almost give you 7. So, I see someone who's seizing the moment.
Hi, everyone. I didn't have a poster, so I'll take the chance. So something I'm wondering about here is, the whole tension between kind of proper analysis and thinking about this and the complexity of it on the one hand versus very simple, fit for purpose, actionable things on the other hand. And then, and we've seen a lot the context specificities, how different stakeholders, are affected in different ways. The one point raised in our group was kind of, can we generalize or something following on from that discussion, can we generalize some of these aspects? So, in the same way that we talk about win-wins in a multi-hazard warning system or in awareness raising on what you do to respond to early warnings, are there some common things that would be useful, for most of these hazards? And what are those ones? And can we, include them in school curriculums? The one example I wanted to allude to in our discussion, also someone made the point that, for example, for earthquakes and tsunamis, it takes a very long time in areas affected by those to build the awareness in the population of, if this event occurs, this is what you do. But, how can we simplify things, I guess, without, losing the resolution? And it's a question of kind of scale in time and space, and a resolution question also.
Thanks. Are there any last comments? I see Neville is really excited to use the last 5 minutes. Oh, I got 2 hands.
Thank you. Maybe just following on that, I gave the example of the earthquakes because it's also linked to one of the comments there about the population the community doesn't want to leave their houses because they're going to be looted so that's what I meant, that it takes sometimes years to convince the population to provide the information about what these warnings mean. And for earthquakes, for example, we had in Mexico one of the biggest one in 1986. And at that time, a lot of people died because there were no warnings. But now we have an alarm that it warns you between 1 and 3 minutes before the earthquake. And people were informed about what to do during an earthquake, where to go, which points. We also have another alarm that is for a volcano. And with the volcano is exactly the same thing. People, this is in rural areas, they don't want to leave their houses, but it has taken the government and other groups time to inform the population on how to live, why they have to live. And the army comes and help them to move out when there is an alarm. That's probably the only good time that we have with the army there. But I mean, they do the work that they are supposed to be doing, and maybe we should move into something like that also with climate change extreme events.
Thank you. It's a good plan.
Yeah, just to tease Neville, really. But if you look at Tim Lenton's stuff on tipping points and so on, we really close to the end of the Holocene, the end of our period of building the civilization that we have. One wonders, some countries are going to be seriously disadvantaged. Just with sea level rise alone, Cheerio, the Netherlands, huge areas of China could potentially be underwater. Our trade partners in Europe would be seriously disadvantaged. Just for fun, it's been interesting to think about how South Africa could make the most, and Africa make the most of our trading partners suffering as we end the Holocene.
All the things those northern funders haven't thought about. Neville, can I hand over to you?
Yeah, thanks very much for that. Thanks, folks. The good news is that the caterers are ready for us, so we can end in peace, so to speak, follow on from your analogy. Yeah, I mean, I can editorialize. I don't think it's necessary. I do like this idea of nodes or synapses, which are at a certain level from which internal local processes happen and then filter back up. I like that idea. And Rocio's input now on the earthquakes and the, again, it's like I was thinking maybe the kinds of hazards that are more typical for certain areas are the kinds you could focus on and so on. So there's lots for us to think about. I'm very grateful. I was going to end this with a demographic test. I'm going to say something to you and I want to see if you know where it comes from, then put up your hand. And the quote is, don't it always seem to go that you don't know what you've got till it's gone? Let me just see who's putting their hands up. Don't it always seem to go that you don't know what you got till it's gone? Let me see. Interesting. It's from a song by Joni Mitchell. And it's an old song. It's from the 60s, actually. Although she wasn't talking about infrastructure. She was talking about love. Nevertheless, I still think it applies. So listen, thank you all for sticking it out. And please recall that 1/3 of the people that have prepared for this conference are presenting tomorrow. And the most interesting and exciting part of the whole event is going to be tomorrow. So, so we encourage you to be here on time and please enjoy the event that's been paid for by you, by your taxpayers' money. And we'll see you tomorrow morning at 8:30, right? Thanks very much.